Hello. Welcome to the 5th EAI International Conference on Machine Learning and Intelligent Communications. My name is Minxiang Guan, the General Chair of this conference. I'm from Shenzhen Institute of Information Technology. Here are the topics of this conference, including intelligent resource allocation schemes, applications of neural network and deep learning, decentralized learning for wireless communication systems, intelligent antenna design and dynamic configuration, intelligent communications, intelligent positioning and navigation systems, intelligent space and terrestrial and integrated networks, machine learning algorithm and intelligent networks, machine learning and information processing in wireless sensor networks, and finally, smart unmanned vehicular technology. These are the topics for MLICOM 2020. Here's the conference history. MLICOM started from 2016 in Shanghai, China, and 2017 in Weihai, China, and 2018 Hangzhou, and last year 2019 in Nanjing, People's Republic of China. And now it's the 5th conference this year. This is an online conference for 2020. So altogether, there are 4, including this year's the 5th conference. And here are the organizing committee members. General chairs are Minxiang Guan, myself, from Shenzhen Institute of Information Technology, and Zhiliang Xu, also from Shenzhen Institute of Information Technology, and Qin Guo from Harbin Institute of Technology. The program chairs are Tintin Zhang from Harbin Institute of Technology, Shenzhen, Guangliang Liu from Harbin Institute of Technology, Weihai, Nan Zhao, Dalian University of Technology. And the web chairs are Yinjie Cui from Shenzhen Institute of Information Technology, Lei Ning from Shenzhen Technology University, Zhou Wu from Shenzhen Institute of Information Technology, and the workshop chairs are Xinling Huang from Tongji University, Weidang Lu from Zhejiang University of Technology, and Bao Li from Harbin Institute of Technology, Weihai. And also, public city chairs are Mu Zhou from Chongqing University of Post and Telecommunications, Zhou Yuna from Dalian Maritime University, Jiang Deng from Harbin Engineering University. The publication chairs are Bao Peng from Shenzhen Institute of Information Technology, Wei Zhizhong from Nanjing University of Aeronautic and Astronautics, Mingchan Yang from Harbin Institute of Technology, Shenzhen. And the sponsorship and exhibit chairs are Shaohua Wu from Harbin Institute of Technology, Shenzhen, Hui Li from Hainan University, and Dean Luo from Shenzhen Institute of Information Technology. The submissions and review. The number of all the submissions are 133 full papers. We received 133 full papers, and each paper is reviewed by 3 TPC members. And finally, there are 66 accepted papers for presentation. So the acceptance rate is 49.6%. So these are the numbers of submissions and the review process and the acceptance rates for this conference. And for the general and special issues, we are going to submit the selected papers to the Wireless Networks Journal. The impact factor is 2.659, and also the Mobile Networks and Applications Journal, and the impact factors is 2.602. And here are the sections and the technical program highlights for day 1. In room number 1 includes the sections of intelligent communications from 9 o'clock to 11:30, and intelligent resource allocation schemes from 13 to 16 o'clock. Room number 2, intelligent antenna design and dynamic configurations from 9 to 10:15. Intelligent positioning and navigation systems from 10:30 to 11:45. Machine learning algorithm and intelligent networks from 13 to 13:30. Machine learning and information processing in wireless sensor networks from 13:45 to 14 o'clock. And decentralized learning for wireless communication systems from 14:15 to 14:45. And for the day 2, in room number 1, intelligent communications from 9 to 11:30, and the section of intelligent resource allocation schemes from 13 to 16 o'clock. And in room number 2, intelligent antenna design and dynamic configuration from 9 o'clock to 10:15. Intelligent positioning and navigation systems from 10:30 to 11:45. Machine learning algorithm and intelligent networks from 13 o'clock to 13:30. Machine learning and information processing in wireless sensor networks from 13:45 to 14 o'clock. And decentralized learning for wireless communication systems from 14:15 to 14:45. So this is the schedule of day 2. And this is the end. Thank you very much.
Dear ladies and gentlemen, let me welcome you to EAI MLICOM 2020 conference held in this virtual interactive setting. I am Karolina Marcinova, the EAI conference manager of MLICOM 2020. Unfortunately, I am not able to meet all of you in person, so I am using this opportunity to address the organizing committee, the keynote speakers, the authors, and the participants on behalf of EAI. I would like to thank all of you for being a part of this conference and for your involvement with EAI. In particular, I would like to thank the whole organizing committee for their hard and excellent work throughout the whole process of the conference preparation. Today, during this streaming, you can actively participate in 2 ways. Firstly, you can join the Q&A on Slack through a link that you can see below this video. Upon accessing the EAI MLICOM 2020 Slack workspace, you can enter all the channels, which are divided by sessions. Secondly, you can vote on individual presentations and leave your fellow presenters feedback on their work through EAI Compass. We will shortly show you how to access this platform and how to leave and receive feedback for presentations in this conference. I would like to use this message to invite you to join us again at EAI MLICOM 2021. Should you be interested in becoming a part of next year's organizing committee or the technical program committee, please do not hesitate to contact me at my email address below. Similarly, if you are interested in discussing other possible cooperation, a conference or a workshop or a new event altogether, please contact me at my email address as well. Now, my colleague Michal will present you with what EAI does, who we are, and how you can get involved in our various activities. Thank you for your attention and enjoy EAI MLICOM 2020.
Hi everyone, my name is Michal Dudic. I'm the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI Index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work-in-progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Hello everyone, my name is Su Xin from the Communication Research Center of Harbin Institute of Technology. I'm glad to have the opportunity to share this paper. The title of my paper is a D2T research scheduling algorithm based on position relation in cellular network. I will explain the algorithm proposed in this paper from the following 5 aspects. There are introduction, system model, the proposed method, simulation and analysis, and the conclusion. First is the introduction. D2D technology refers to data transmission between two terminals with relatively close locations, using a direct link without forwarding through the base station. It is listed as one of the key technologies in the 5G mobile communication system. D2D technology in cellular mobile networks can improve spectrum utilization and system throughput. The contradiction between numerous user equipment and limited spectrum resources cannot be ignored, and it is easy to cause cross-channel interference, which is called CCI. Common solutions include precoding algorithms and resource management algorithms. The precoding algorithms calculates the appropriate coding method by estimating the channel information, thereby facilitating the smooth recovery of the signal at the receiver. Resource management algorithms are often combined with other technologies to study frequency selection and power control issues of D2D technology. Therefore, the keywords of this paper are D2D, resource scheduling, and location relationship. Second is a system model. The D2D channel in the cellular network is different from the channel of the cellular users. because the antennas of the transmitter and the receiver of the D2D user are very low compared to the base station, and will interact with a large number of scatter rays. Therefore, in most literatures, the channel model is set to large-scale path loss and rarely fading channels. Considering the above model, the power received by the base station from the cellular transmit is as shown. In the uplink, the base station acts as the receiver and does not interfere with other users. So, this paper studies the issue of multiplexing resources for D2D users in the uplink. Consider the situation shown in Picture 1. When the same antenna of CT1 and CT2 is received at the same BS, their SINR are respectively as shown. Assuming that the minimum SINR for the user to guarantee the communication quality is above 0, so it is impossible to guarantee the QoS of two CTs at the same time. Therefore, there can only be one CT user on the same frequency under a signal antenna. Also, it can be seen that the distance from the DT to the BS needs to be greater than the distance from the CT to the BS. Third is a proposed method. Study the constraint first. There are two quantities that have little effect on the algorithm. One is the transmission power. Since most users in the cellular network are smartphones, there is an approximate relationship of P1 equals P2. Other is the channel attenuation coefficient, because H follows the distribution Cn01, having little effect on D and P. So it is approximately regarded as the case of no attenuation. Analyze the situation of DR being disturbed. Amusing that the minimum distance between the transmitter in the same frequency band and the DR is dmin, and the distance d between the same pair of dt and DR is much smaller than dB. Neglecting small amounts, then the transmitter in the same frequency band on DR are equivalently, and the course of maximum interference will be as shown in Picture 2. The positional relationship of the equilateral triangle is extended outward, and the distance between each pair is dmin. If the layer is extended outwards, the radius of the occupied area increasing by dmin. To future discussion is the situation in figure 2b. Suppose that there are NDTs equidistantly arranged on a circle with a radius of r2 at a distance of d min. In order to simulate the CCI situation of CT and estimate the R1 and R2 relationship, this left is shown that quantities such as SINR, dmin, and B is represent the distance index, which can be calculated in this pair. For further discussion, we can see that the quantity R1 and R2 have the relationship as shown. Next, study the objective function. Through the study of the positional relationship, it is found that when the user interval of the same frequency band is large and the number is small, the CCI is small. So consider the quantity variance that can measure the degree of dispersion of positions as a system indicator. The position is x. The position of one user is shown with x and y. The objective function is the maximum sum of variance of all points in the k frequency bands. Fourth is the simulation and analysis. Changing the spacing d of d2d user pairs. The minimum interval d min changes as shown in figure 3a. When d is 50 meters, d min is about 204 meters. And the cell radius is between from 2d mins to 3d mins. That is, the two-layer dense arrangement is suitable as the analyzed condition. The current in figure 3b is the value of R2 and R1. The fashionable region is the area about the carbon where satisfying. The DT is at least 32 meters away from the BS. When the distance between the CT and the BS is greater than 101.1 meters, the cell will not be able to accommodate D2D communication in the same frequency band. When the frequency resources are sufficient, algorithm 1 and algorithm 2 have little differences in the total data transfer and the system capacity. When the total number of users is increasing algorithm 2 have a higher data transmission rate, but algorithm 1 has a larger system capacity. In this simulation, the system capacity of algorithm 1 is 65 and the system capacity of the algorithm 2 is 55. Finally, is the conclusion. This paper proposes a D2D resource scheduling algorithm based on location relationship. The algorithm uses the sum of variance as a performance index, pursues the dispersion in the user space to reduce CCI, and determines constructs by positional relationship between the 2D user and the cellular user to ensure the user's communication quality. Experiment results show that the algorithm proposed in this paper maintains a good data transfer rate and has low computational complexity and a higher system capacity. The next step of research can be deep in the direction of improving system throughput. The reference of this paper is shown as below. That's all. Thank you for listening.
Hello everyone, my name is Sun Jiaqi. I'm from Harbin Institute of Technology. The topic of my presentation is a radio communication integrated signal, or OFDM, based on 4-phase code. My presentation will include these 4 parts. First, the background of our research. Second, the signal model and ambiguity function. Third, 4-phase code and information transmission. And the last, simulation results and the conclusion we have got. Firstly, I would like to introduce the background of our research. In recent years, Internet of Vehicles and driverless cars are developing rapidly. In these scenarios, vehicles need to know the information of each other, such as distance and velocity. At the same time, vehicles need to communicate with each other to share information. This picture shows the scenery of traffic. For example, these cars are driverless. Different cars need to know necessary information such as distance and velocity to control themselves, and they need to transmit their information to others. The acquisition of distance and velocity information between vehicles depends on radar system. The communication of different vehicles depends on communication system. It is likely to be electromagnetic interference if the 2 systems implement separately. Radar communication integrated signal can improve spectral utilization ratio and reduce interference between devices, so it is significant to research radar communication integrated signal. Figure 1 shows the working principle of radar communication integrated signal. As the figure shows, one vehicle transmits the radar communication integrated signal. Then the signal will arrive on another vehicle. The signal will reflect, and the echo is used to measure distance and velocity. At the same time, the integrated signal can be demodulated and the vehicle can get information from the signal. In the design of radio communication integrated signal, OFDM, which is widely used in communication systems, has many advantages. For instance, it is easily synchronized and equalized, and it has high spectral efficiency. As a radar signal, OFDM has good detection performance. Therefore, we use OFDM to design radar communication integrated signal. The overall of our design can be seen in the follow chart. First, we construct a model of OFDM radar communication integrated signal. Second, we construct 4-phase coded sequence set. Third, we optimize sequences, use GA. Fourth, we let the sequences carry information. And the last, we combine OFDM radar communication integrated signal with 4-phase code. Then, I would like to introduce the signal model in our paper. Suppose that each pulse consists of n OFDM symbols. Each OFDM symbol has m subcarriers. The baseband signal can be expressed in the following form. Figure 2 shows time frequency domain representation of radar communication integrated signal of OFDM. As we can see, there are n subpulses in a pulse, and each subpulse is an OFDM symbol. Each subpulse has m subcarriers. The ambiguity function of radar, which is related to the transmitted waveform, is an effective tool for radar signal analysis and waveform design to get high resolution of distance and Doppler. An ideal ambiguity function should be the shape of pupil. The design of ambiguity function is that its function st is the radar signal we will analyze. The function we can know the ambiguity function is only related to the signal. Bring OFDM radar communication integrated signal to radar ambiguity function. By simplification of formula and analysis, we can get a conclusion. The communication information modulated on different OFDM symbol should have good autocorrelation and cross-correlation properties for good ambiguity function. As we can see in the figure, each column should have good autocorrelation property, and different columns should have good cross-correlation property. Then I will introduce genetic algorithm simply. Genetic algorithm is an analog of biological evolution. It can solve optimization problem by robust and adaptive searching. The main step of GA is encoding the results to population and optimizing the results by selection, crossover, and mutation. The specific steps of GA are listed as follows. Step 1. Code the actual problem and generate the initial population randomly. The initial population represents initial solutions. Step 2. Design the fitness function. Each individual in population has a value of fitness function. Initialize the probability of crossover and mutation. Third, select a part of population to do crossover and mutation. Then we get new population. Step 4. Calculate the fitness function value of the new population. If the new population meets the requirements, output the results, or else drop to step 3. Then I would like to introduce 4-phase code. Through the above analysis, we know the communication information modulated on different OFDM symbols should have good autocorrelation and cross-correlation properties for good shape of ambiguity function. In order to ensure the performance of reader detection, we construct polyphase code sequence set. 4-phase coded sequence is selected in this paper. The reason is that the random 4-phase coded sequences have good autocorrelation and cross-correlation properties. Then using genetic algorithm to optimize them, the sequences can have better autocorrelation and cross-correlation properties. Suppose the sequence set has L sequences. The length of each one is n. The sequence set can be expressed as this. The autocorrelation and cross-correlation of 4-phase coded sequences can be expressed as this. GA is used to optimize autocorrelation and cross-correlation properties. In order to make different sequences have good autocorrelation and cross-correlation properties, we define cost function as. In order to use GA, we should expand out our sequence set. In particular, each individual of GA can be expressed as phi11 to phi Li. Let f be the adaptability function. Then go into the loop. After GA processing, more orthogonal sequence set can be got. The processed sequence set doesn't carry information itself, but we can map information to the sequences. Different permutations of sequences can map different information. In this way, the same information can be mapped to different sequences, and the performance of reader detection is guaranteed. For convenience of expression, we let percent equal to this. For example, when L equal to 3, the information bit 0, 0 can be mapped to percent 1, percent 2, percent 3, and 0, 1 can be mapped to percent 1, percent 3, percent 2. It is worth noting that the permutation of L sequences will be used to transmit information, which can reduce communication rate compared with transmitting information directly using the same signal model. The actual communication rate R1 can be expanded by expanding the size of the sequence set. The number of subcarrier in an OFDM symbol and the number of OFDM in a pause. Reducing the period of OFDM symbol is also a choice. Then I would like to introduce the simulation results. In the simulation, we set an OFDM symbol period to 0.1 microsecond. One OFDM symbol has 40 subcarriers, and one pulse has 40 OFDM symbols. The size of the 4-phase coded sequence set is 80 multiple 40. two sequences are randomly selected in the set, and Figure 3 shows their cross-correlation and autocorrelation. As can be seen from Figure 3, the 4-phase coded sequences have good autocorrelation and cross-correlation properties. By the previous analysis, we know these sequences meet the requirement of radar communication integrated signal or OFDM. We select 40 sequences from the set randomly. Figure 4 and Figure 5 show the ambiguity function. As can be seen from Figure 4 and Figure 5, the ambiguity function has a single central peak, and the rest of energy is evenly distributed across the distance and the Doppler plane. It shows that the radar communication integrated signal of OFDM using 4-phase coded sequences has good detection performance. In the end, I would like to introduce the conclusion of our research. In this paper, a radar communication integrated signal of OFDM based on 4-phase code is proposed. The simulation results show that the 4-phase coded sequences optimized by GA have good autocorrelation and cross-correlation properties, and the radar communication integrated signal using these sequences has good radar detection capability. Also compared with direct transmitting information, the rate of communication is lower. It ensures radar performance, and the rate of communication can be increased by changing the parameters. The radar communication integrated signal designed in this paper can be applied to driverless operation system, which requires good radar detection performance and stable communication rates. That's all for my presentation. Thank you.
Ladies and gentlemen, the title of our research is a two-step phase-shifting phase retrieval algorithm based on orthogonal characteristics of interferograms. The main content of the report are as follows. First, the introduction of our research. Secondly, the principle of the proposed method. And thirdly, the numerical simulation. Finally, the experimental results are presented to verify the effectiveness of the proposed method in this paper. As a high-precision optical measurement technology, optical phase-shifting interferometry has been widely used in various fields of scientific researches and engineering applications. The traditional phase-shifting phase retrieval method, which called n-step phase-shifting algorithm, where n is greater or equal to 3, is to recover the phase to be measured by calculating n frame of phase-shifting interferograms with a phase shift equal or a fixed value, mostly 90 degrees, such as equal step algorithm and fixed step algorithm. These methods have high requirements on the amount of phase shift. In order to obtain high precision of phase information, such algorithms usually need to calibrate the phase shifter. Obviously, the the phase shift error is one of the main factors affecting the accuracy of the traditional phase-shifting phase retrieval algorithm. For the needs of practical engineering applications, it's necessary to study the phase-shifting phase measurement method when the phase shift amount is unknown or random. Two-step phase-shifting interferometry, which can retrieve the phase quickly and accurately from the least amount of phase-shifting interferograms with unknown and random phase shifts. The obtained results in a wide range are not affected by the amount of the phase shifts, which is beneficial to reduce the influence of the environmental factors such as vibration and airflow changes, and can be used in dynamical phase measurement. However, in most two-step algorithms, it's necessary to eliminate the background in advance, which means that the accuracy of phase retrieval is greatly correlated with the background atoms of the interferograms. Currently, there are two methods to eliminate the background atoms. Firstly, with a filter in the frequency domain, and secondly, through interferogram subtraction. For interferograms with slowly changing background intensity, the background atoms can be eliminated with a filter in the frequency domain. However, for interferograms with high-frequency background intensity changes, although the method of filtering in the frequency domain can filter out the background part, the high-frequency phase information has also been filtered out. In addition, the choice of filter window size has a direct and important influence on the accuracy of the two-step algorithm. This will bring certain errors to the measurement results. To resolve such problems, interferogram subtraction method is employed to remove background atoms. The measured phase with high precision can be retrieved rapidly and easily. In this work, combined with the interferogram subtraction and the orthogonal characteristics of these interferograms, a two-step phase-shifting phase retrieval algorithm is proposed to reconstruct the measured phase rapidly and accurately. Following, we will introduce the principle of the proposed method and then present the corresponding numerical simulation and experiment results. In general, the intensity distribution of the MS pixel in the nth phase-shifting interferograms IMN can be described as an ideal sinusoidal matrix as follows. Well, N represent the sequence number of the phase-shifting interferograms. The lowercase letters m represent the pixel position, while the uppercase letter m is the total pixel number of the interferogram. AM, BM, and phi-m respectively denote the background intensity, the modulation amplitude, and the measured phase, respectively. The delta n is the unknown phase shift of the nth interferogram. For simplicity, we define theta 1 equal to 0. Subtracting the first interferogram from the second and the third interferograms, respectively, we can get two differential interferograms expressed as the following expressions. We can see that the background intensity has been eliminated by the simple subtraction operations. In practical phase-shifting interferometry, the phase shifts between different interferograms are different. Therefore, the amplitude of the two differential interferograms are different. The normalization approach has been introduced to eliminate the influence of the phase shift on the amplitude of differential interferograms. Normalizing the two differential interferograms, we will get to formula as follows. When the fringe number in the interferogram is more than 1, there will be the following approximation. Thus, the normalized differential interferograms can be rewritten as if there is more than one fringe in the interferograms, we have the approximation as follows, which means the lengths of dm1 and dm2 are approximately equal, and they can be regarded as equal length vectors. According to the law of parallelograms of vectors, we can see that the sum and subtraction of the two equal length vectors are the diagonal vectors of the diamond, which formed by these two equal length vectors, and these two diagonal vectors are orthogonal to each other. The two orthogonal diagonal vectors of the diamond can be expressed as normalizing the two orthogonal diagonal vectors, we will get if there is more than one fringe in the interferograms, the measure phase can be obtained by an arctangent function as through the above process, and after phase unpacking, the true phase distribution of the object to be measured can be obtained. Numerical simulation is carried out to verify the effectiveness of the proposed method. First of all, 3 frames of simulated phase-shifting interferograms are generated according to the first equation. In addition, to coincide with the actual experiment condition, a Gaussian additive noise with signal-to-noise of 5% is added to the simulated interferograms. Figure 1-C shows 3 frame simulated phase-shifting interferograms. We can get 2 frames of differential interferogram by subtracting figure 1A from figure 1B and C respectively, as shown in figure 1D and figure 1E. Figure 1F shows the cyclotic phase. The unwrapped phase of the proposed method is shown in figure 1G. In contrast, to compare the accuracy of the phase distribution by the proposed algorithm with the other algorithms, the phase extraction are also performed with the EAI, PCA, GS2, DDV, GS3, and the proposed method, in which the numbers of fringe patterns are set as 32 for EAI and PCA, 3 for GS3, 2 for DDV and GS2. For EAI and PCA, the amount of the phase shift between two adjacent interferogram is 0.1 rad. Conventional Gaussian high-pass filter has been utilized to eliminate the background atom in the algorithm of JS2 and DDV. The phase difference between the cellular phase and the unwrapped phase with the EAI, PCA, JS2, DDV, JS3, and the proposed math algorithm are respectively shown in Fig 2a to 2f. Moreover, to compare the calculating speed and the error of the phase extraction with different algorithms, the processing time and the root mean square error of the difference between the cellular phase and the extracted phase with the EAI, PCA, JS2, DDV, JS3, and the proposed method are respectively shown in Table 1. All results are obtained with a 2.5 GHz laptop and MATLAB. Obviously, it can be seen that the processing time of the proposed method in this paper is less than all other methods. In addition, the RMSE with the proposed method is the same with the JS3 and is close to the time-consuming EAI algorithm. The result is far less than the PCA, JS2, and DDV algorithm. Obviously, due to the accuracy of the phase extraction with the EAI algorithm being higher than those with other algorithms, in our case, it should be reasonable to employ the extracted phase with the EAI algorithms as a reference phase. To further verify the effectiveness of the proposed method, the proposed algorithm in this paper is also employed to perform the phase extraction in the experimental phase shifting interferograms. As shown in Figure 3, 3-frame interferograms, which are selected randomly from 32-frame phase shifting interferograms and used as a data source for the phase extraction with the proposed method. Firstly, the unwrapped phase map obtained by EAI with 32-frame phase shifting interferograms is used as a reference phase, as shown in Figure 4a. Then the difference between the referenced EAI algorithm and the unwrapped phase maps with PCA, JS2, DDV, JS3 algorithm and the proposed method are respectively shown in Figure 4b to Figure 4f. Then the corresponding RMSE of the differences between the unwrapped phase with the EAI algorithm and the unwrapped phase with the PCA, JS2, DDV, JS3, and the proposed algorithm, as well as the proposed time of phase extraction are shown in Table 2. Clearly, like the simulation analysis, the processing time of the proposed method in this paper is less than all other methods. In addition, the RMSE with the proposed method is the same with the JS3 and is close to the time-consuming EAI algorithm. The result is far less than the PCA, JS2, and DDV algorithm. The experimental results indicating that the proposed method is suitable for the phase extraction with high precision and fast speed. My report is over. Thank you for listening.
I'm honored and proud to have the opportunity to speak at this meeting. I'm Zheng Xu from Shenzhen University of Technology. The name of the paper I will reduce for you is An Empirical Comparison of Implementation Efficiency of Iterative and Recursive Algorithms of Fast Fourier Transform, and the team includes Lin, Zheng Xu, He Huan, Zhao Jian, and Liang Lixing. My explanation includes 4 parts: introduction, implementation methods, experiment, and conclusion. In 1807, French scientist Fourier took the lead in using sine curve to carry out research on the thermal. In 1822, he published his research result in the landmark work Analytical Theory of Heat, which detailed the Fourier series and the Fourier integral theory. Fourier transform is a method of signal analysis which can realize the conversion of signal between time domain and frequency domain. However, for a long time since the establishment of Fourier transform, it makes sense for the theoretical analysis, but it was difficult to apply in engineering practice because of the limitation in its huge computational complexity. A great breakthrough was made in 1965 when Colli and Tukey proposed the famous Fast Fourier Transform, which significantly reduced the time complexity of the algorithm. There are 2 ways to implement Fast Fourier Transform on the computer: iterative algorithm and recursive algorithm. It is generally believed that the iterative algorithm implementation process is complicated and difficult to understand, but the program can run at high efficiency. On the contrary, the recursive algorithm has a clear code structure and is easy to understand because of its better readability. The disadvantage is that the recursive program takes more time to run, and the code efficiency will drop sharply as the scale of the problem increases. In this study, we attempt to implement iterative and recursive algorithms of FFT using 4 mainstream object-oriented languages: Java, C#, C++, and Python, which test the runtime of these 2 algorithms on Windows, Mac, and Linux operating system. Study the performance of these 2 algorithms in different platforms and different compilation environments using statistical methods, and conduct a reasonable analysis and discussion. If an endpoint discrete signal sequence is given, then the case Fourier coefficient can be expressed by Fourier 1. The DFT of endpoint sequence depends only on the n half-point subsequences, so the FFT of the entire sequence can be obtained by iterative calculation. That is so-called iterative algorithm of FFT. In computer programming, iteration can be realized by loop nesting. The flowchart is shown in Figure A. From another perspective, Each sequence in FFT butterfly operation calculates and divided the subsequence in the same way. If this process is encapsulated into a function, the operations at each layer can be implemented by this function. When calling a function, there is a direct call to the function itself until the sequence becomes only one data. That is a typical recursive problem, and this calculation method is so-called recursive algorithm of FFT, which is shown in Figure B. In our study, the performance of iterative and recursive algorithms of FFT with C++, C#, Java, and Python languages on Windows, Mac, and Linux operating systems are studied. For the better accuracy of the experiment, computers with similar hardware configuration are used. Table 1 shows the information about the hardware and the operating system of experimental computers. And Table 2 shows the compilers of 4 programming languages in 3 platforms. We use Java, Python, C++, and C# to implement iterative and recursive algorithms of Fast Fourier Transform on Windows, Linux, and Mac platforms, respectively. Run each program 10 times with input data of a random sequence of length n equals 2m, and record the experiment result in billion seconds for data analysis. This figure shows the runtime of Fast Fourier Transform algorithm written in 4 mainstream languages on 3 platforms. The 3 subgraphs all use a base 2 logarithmic coordinate system, where the abscissa is the sequence number of FFT. The ordinate is the runtime of algorithm in milliseconds, and the data points in the graph represent the advantage time of running time times. Figure ABC shows experimental data on Windows, Linux, and Mac platforms. The curves under all platforms show that as the length of the sequence increases, whether it is the iterative algorithm or the recursive algorithm, in overall, when the sequence is short, the runtime of C++ program is shortest, followed by Python and Java, while that of C# is the longest. When the sequence is long, the runtime of C++, C# and Java is close, while that of Python is much longer. Python is an interpreted language that dynamically changes its structure at runtime. In each progress of running the code, the Python parser first converts it into bytecode, which is then converted to machine language by the virtual machine. Compared with Java and C# languages, the process is more complicated. In the environment with small data size, the difference between the 3 is not big, but when the amount of data being processed is large, the performance of Python will be significantly affected, and the runtime is significantly larger than Java and C#. In order to further study the similarities and differences between the iterative algorithm and the recursive algorithm, this study uses statistical method to perform paired t-tests on the measured data to verify whether the runtime of these two algorithms is statistically different. As can be seen from Figure 3, when the sequence length is small, the efficiency of the iterative algorithm and the recursive algorithm is related to the programming language and operating system. Among them, for C# and Python on Mac operating system, C# and Java on Linux operating system, C# and Java on Windows operating system, the runtime of the iterative algorithm and the recursive algorithm is not significantly different. In this study, the rate of runtime RORT of the two algorithms is used as an indicator to measure the time efficiency, defined as RORT, where Ti represents the runtime of the iterative algorithm and Tr represents the runtime of the recursive algorithm. As can be seen from Figure 4, the FFT calculation of the long sequence, the programming language has a greater influence on the efficiency of the algorithm than the operating system. For Java, when the sequence length is less than 1024, the runtime of the iterative algorithm is smaller than that of the recursive algorithm. When the sequence length is greater than 1024, the running efficiency of the recursive algorithm is better than that of the iterative algorithm. This phenomenon is related to Java's JTI compiler. When the same function is called repeatedly in a program, the JIT compiler dynamically optimized the recursive code. These two algorithms have their own advantages and disadvantages. It is generally believed that the iterative algorithm is more efficient than the recursive algorithm. This study uses iterative and recursive algorithm of FFT in Java, C#, C++, and Python, and tests the runtime of the iterative algorithm and the recursive algorithm on Windows, Mac, and Linux platforms. The experimental results show that the program written in Python has the longest runtime. Whether it is the iterative or recursive algorithm, the iterative algorithm written in C++ has the highest running efficiency, and its phenomenon has little relationship with the operating system. The paired t-test is performed on the experimental data of iterator and the recursive algorithm. The results show that the sequence length has an impact on the runtime. In the case of a long sequence, iterative and recursive algorithms have statistically significant differences. Further calculating the rate of runtime of iterative and recursive algorithm for different sequence lengths shows that the iterative program written by C++, C#, and Python is better than the recursive algorithm, while Java is the opposite, where the efficiency of the recursive algorithm is better than that of the iterative algorithm. The research conclusions of the paper have certain guiding significance for engineering practice and provide a reference basis for engineers to select programming language and implementation of reason for FFT. This is our reference. The above is my report. Thank you.
Good morning, everyone. My presentation includes 5 parts. Firstly, I will begin with a background of Amplify-and-Forward system. AF is an important relaying strategy in which one or more relays amplify the source signal to complete the communication between the source node and the destination node. It can extend wireless network coverage or improve communication quality, and is widely used in wireless communication system, wireless sensor system, and so on, especially in the communication networks of military, government, and financial institutions, where the relay node must be regarded as eavesdropper node. AF is more suffer than decode and forward scheme. As we know, power allocation of wireless communication system plays a vitally important role, so it is always a field that attracts much more attention. Many researchers have studied the AF system with cooperative diversity scheme or selection scheme of choosing the best relay node. The paper aims to provide an optimal power allocation for the AF system, that the power must be allocated among all source nodes and relay nodes, where the total system power is limited, where the system performance is assessed with SNR. Secondly, I will have a brief introduction of the proposed model. Figure 1 shows the proposed AF system, in which no direct link exists between the source SM and destination D. Here M is equal to 1, 2, and so on. The sources communicate with the destination D with the assistance of L parallel relay nodes Ri. Here I is equal to 1, 2, and so on. The destination collects all signals that are amplified and retransmitted by the relays with equal weight and recovers original information. Assume that the original signal XM generated from source SM follows Gaussian distribution N. The noise in every relay node and the destination is independently and identically distributed, additive wide Gaussian noise, and orbits N. Meanwhile, all the wireless channel between source nodes and relay nodes, as well as that between relay nodes and destination nodes are all Gaussian channels. It should be mentioned that here what we considered is a theoretical analysis framework, including mechanism and access probability are not taken into account. Furthermore, the number of source nodes and relay nodes are all more than 1, while the character of the structure of the AF system makes it different with the MIMO system. The technologies and their relative theories of MIMO system, such as beam design, antenna selection, and so on, are not thought about. When the signal XM that generated from the M's source reaches the R's relay node Ri, we can obtain the following equations. Here is the signal, and it is the power of the signal. Here m is equal to 1 to up to m. I is equal to 1 to and up to L. The R's relay node amplifies the power of the received signal for beta times. Here, beta is defined as this one. The signal received by the destination from the I's relay node and its power can be presented in the following forms. This is the signal and this is the power of it. And the power of YDI is this one. So from it we can get the SNR of YDI. It can be written as this one. Here we assume that the total power of all sources and all relays are limited, and the power of every relay node is equally distributed. One can find the following expression. Considering that the power of every source node Px should be lower than the total power P, the maximum SNR at the destination of the AF system can be described as a constraint optimization problem. Then I will have a detailed introduction on how to get the optimized power allocation and maximized SNR. If we make gamma A the function with respect to a variable Px divided P, the following expression can be obtained. It is the maximum of gamma A. To solve this problem, here we define this one. Then we can obtain the maximum of gamma A can be written as this one. Here, phi Px divided P can be written as this form. After some processes, we can at last get the minimum phi Px divided by P can be expressed as the square of two items. Then the maximum SNR of the F system is written as a function of several variables, like this one. The corresponding powers of every source node and every reading node are expressed here. Now, some numerical result will be shown. All signals are transmitted in free space, and the channel attenuation factors are obtained from the free space propagation formula. Carrier frequency is 2.5 GHz. The distances between source nodes and reading nodes are 400 meters, and the distances between reading nodes and the destination node are also 400 meters. The total system power is assumed as 10 watts, and the power of the noise is this one. From Figure 2, we can see that the SNRs at destination of the two schemes grew with the increase of the number of reading nodes, which are consistent with the previous study. The reason is that more reading nodes bring more source-ready destination sublinks and a higher gain in the destination. It should be pointed out that the SNR of the proposed optimized method always outperforms that of the scheme with equal power allocation. Due to the fact that the total system power determines the performance, the plot of SNRs at destination versus the total system power is given in Figure 3, where the number of source nodes and reading nodes are 3 and 10 respectively. Obviously, with the increase of the system power, the SNRs at destination are improved. This is because that the noise power is a constant whatever the system power is. For this reason, the bigger the system power, the higher the SNR. Meanwhile, the SNR of the scheme with equal power allocation is similarly with the proposed one, while its value is a little lower than it. To illustrate how the distance influences the performance, the SNRs at destination with respect to the distance are shown in Figure 4. Here, the distances between the source nodes and the destination nodes are no longer 400 meters. They range from 200 meters to 1,200 meters, and the reading nodes lies in the middle position, and the number of the source nodes and the reading nodes are 3 and 10 respectively. It apparently shows that both of the two values of SNR at destination decrease with the increase of the distance, which is consistent with the experience and fact. For the further distance between the source node and the destination node is, the weaker the received signal is. Wherever for the reading node or the destination node, so the lower the SNR at destination is. Similarly, the SNR of the optimized method outperforms that of the scheme with equal power allocation. Finally, I will have a summary about my research. This paper has proposed an optimized transmitting scheme for the AF system, which includes several source nodes and several parallel relay nodes. By an optimization procedure, we have derived the expression of the SNR and obtained the maximum SNR at the destination. Based on the expression and corresponding parameters, validations by the simulation method have been conducted. The simulation and analysis results have shown that the SNR at the destination of the proposed scheme outperforms the one in which the power is equally allocated among all source and relay nodes. Therefore, in the future, we will combine the model with the sensor networks and apply the scheme to optimize power allocation and the system performance. That's all. Thank you. All questions are welcome.
Hello, editors. My name is Lai Biaojun. Now I will show my paper to you. The title of this paper is Resource Optimization for UAV-Enabled Multichannel Internet of Things. Next, I will describe my paper from the following four aspects. The first is the system model. The second is the solution of a problem. The third is numerical results. And the final part is the conclusions. Okay, this is the system model. There are some IoT nodes on the ground. The UAV is deployed at the stable height. We show that the direct link between the IoT nodes to the data center are ignored. Hence, the UAV is deployed to facilitate one-way communication from IoT nodes to the data center, which can forward the data received from the IoT nodes to the data center. In this paper, the transmit channel is divided into some narrowband sub-channels. We show that the communication channels from the IoT nodes to the relay and the relay to the data center are line of sight links. Therefore, the Doppler efforts can be ignored. Okay, note that time is divided into time slots. Time slot is so small that the position and the span of the UAV in each time slot is constant. The concentration on UAV trajectory can be described as follows. That is, the displacement of UAV within one time slot is less than the maximum displacement. According to the Shannon's formula, the maximum transmit rate for source and relay can be described as follows. This is the subcarrier factor, and this is the power. Finally, this is the time-dependent channel-to-node power ratios. Hence, the problem can be described as follows. The first is the information causality constraint. That is the power constraints. The problem is non-convex, so we will count through it directly, but we will through it by some ways. This is the solution of the problem. We divided the problem into four parts. And the first is the subcarrier allocation. The second is the power optimization. The third is the trajectory optimization. And finally is the joint optimization. The subcarriers can be allocated to the nodes according to the channel gains, which are constant within one time slot. To guarantee transmission performance, one subcarrier is allocated to the node with the best channel gain on it, and the subcarrier cannot be occupied by other users in this time slot. And so we can get the two formulas. The power optimization problem can be described as follows. we introduced the select variables. The problem is non-convex. So we will use some ways to transform this problem. We apply the word filling algorithm to solve the problem. The problem satisfies the selector's condition, so we can obtain the optimal solution by solving the dual problem. This is the Lagrangian function. We introduce two factors and transform the function into this formula. So the GAN function can be described as follows. The Lagrangian dual problem can be described as follows. We first maximize the Lagrangian to obtain the GAN function, and then find the optimum GAN solutions to minimize the GAN function. Now, by applying the standard Lagrangian method and the KKT conditions, the optimal power values of IoT nodes and UAV can be obtained as follows. The optimum GAN solutions to minimize the GAN function can be obtained by applying ellipsoid method. So the power optimization problem can be solved. Next, it is the another sub-problem. The Gen optimization can be described as follows. We can also introduce the select variable. The problem is also non-convex, so we will use some ways to solve it. The SAA method to solve the problem is great. By denoting the trajectory incremental, we can obtain the two formula. The convolutions can be described as follows, and they are obtained by applying the first-order Taylor expansion. And now, the problem can be transformed into this problem, and now the problem is a standard convex optimization problem, and so we can solve it by the optimization tool CVX. And now the trajectory optimization can be solved. This is the joint optimization. First, with the given UAV trajectory optimization, we will optimization the subcarrier occasion according to the channel gain. Second, with the given power, we will optimize the UAV's trajectory by solving problem 1.2. And then with given UAV trajectory, we will optimize optimize the power occasion by solving problem 1.1 and until the trajectory is convergent or the maximum number of the iterations has been reached. The numerical is shown. We consider two UAV trajectory. The first is the UAV is stated at the fixed location, and the second is UAV flies from the initial to the final location with the maximum span towards the data center. Then we consider two subcarriers occasion states. One is the subcarriers are damaged accorded at each slot according to the channel gain, and the other is the subcarrier occasion is fixed in the first slot and remain unchanged until the end of the flight. It's observed that the transmit rate on the mobile UAV is higher than that in the state UAV. In addition, the transmission under the damaged subcarrier occasion is higher than that under the subcarrier occasion, the fixed subcarrier occasion. The UAV trajectory by joint optimization algorithm is shown in this figure. It is seen that the UAV first moves towards the IoT nodes and then close to the data center instead of the direct flight. Such a trajectory can guarantee the UAV to receive enough data from the IoT. Finally, in this paper, we propose resource optimization for a UAV enable multi-channel IoT, which seeks to maximize the throughput of the IoT by joint optimizing subcarriers, power, and UAV trajectory. The proposed optimization problems are divided into three sub-optimization problems: subcarrier occasion, the power optimization under the fixed trajectory can be solved by the water filling algorithm, and the trajectory optimization under the fixed power can be achieved by the SCA method. And a joint optimization algorithm is given to obtain the optimal resource occasion. Numerical results show that the proposed resource optimization algorithm can improve the transmission performance of the UAV-enabled multi-channel IoT effectively. That's all. Thank you very much.
paper's name is Research on Anti-Jamming Algorithm of Multi-Antenna System based on Artificial Intelligence Technology. Reporter is Zhou Wu. Abstract. In order to solve the system interference problem caused by beamforming technology of multi-antenna system, an anti-jamming algorithm based on artificial intelligence technology is proposed, and a multi-antenna anti-jamming modem based on artificial intelligence algorithm is constructed. Particle swarm optimization algorithm is used to train and verify the rationality, convergence ability, and performance of the model. Finally, the pattern of the antenna array will form a high gain in a desired direction to enhance the desired signal, while the interference direction will form a zero notch to suppress the interference signal, effectively improve the signal to interference ratio of the receiver, and improve the system performance and increase the system capacity. Introduction. The future communication network will be an intelligent system with multi-services, multi-access technology, and multi-level coverage. Among them, the application of multiple antennas has great prospects and even necessary directions. Multi-beam antenna technology can effectively alleviate the influence of deep feeding caused by multi-path propagation on communication equality through spatial diversity, and increase the reliability of wireless mobile communication systems. Meanwhile, multi-beam antenna with beamforming algorithm as the key technology can realize space division multiple access SDMA by adaptively adjusting the weighting vector of antenna array, enhance expectation, suppress interference. Finally, the space multiplexing or space diversity of communication system is realized, and the capacity of wireless link is greatly improved. As we all know, one of the basic challenges in wireless system design is to manage and allocate resources to meet the traffic demand under difficult conditions. The traditional solution is to analyze and simulate the system based on domain knowledge and experience so as to formulate targeted rulers. The effect of this method mainly depends on the design stage. Once the design is completed, the system will operate according to the preset rulers. In today's network environment, the traffic shows the trend of diversification and dynamic development, and the network and the resources architecture become more complex. So the method is facing more and more challenges. The future wireless communication network will have the ability of self-learning and self-adaptive so as to meet the requirements of user equipment, wireless conditions, and traffic characteristics generated by various applications. By learning the past behavior patterns, output results, and the behavior of similar entities on the unified network or other network, the decision quality of the network will continue to improve. Machine learning and artificial intelligence are the best candidate technologies, which can provide more powerful, complex decision-making capabilities for future wireless systems. In this paper, by studying the anti-jamming strategy of multi-beam decision-making system and the coordination and cooperation between multi-user devices, a multi-antenna anti-jamming model based on artificial intelligence algorithm is stability with ruler set strategies used and expected return function. After the establishment of multi-antenna anti-jamming model based on artificial intelligence algorithm, the model needs to be trained to verify whether the model is reasonable, whether it meets the needs of multi-antenna system anti-jamming, and whether the training results can eventually converge. Particle swarm optimization algorithm is used to train the artificial intelligence model to verify the rationality, convergence ability, and the performance of the model. Finally, the pattern of the antenna array will form a high gain in the desired direction to enhance the desired signal, and a zero notch in the inference direction to suppress interference signal, effectively improve the signal to interference ratio of the receiver, and then improve the system performance and increase the system capacity. System model. It is assumed that there are A users in a multi-antenna communication system, and the number of antenna arrays at the transmitter and the receiver is M. These A users are evenly distributed in a cell. The multi-antenna system model is shown in Figure 1. Then the receiver's signal of the user error can be expressed as equation 1, where is the transmitted signal, assuming that the signal is a generalized stationary signal and represents the channel matrix, assuming that the transmitter has perfectly known the channel information of the user, indicates the transmission weight. For white Gaussian noise vector, we assume then the SINR of the user error can be expressed as equation 2. It can be seen from equation 5 that SINR of each user is affected by the interference of other users. So, in order to suppress the interference of other users and improve their SINR, users need to adjust their transmission power. However, when users adjust their transmission power, they will interfere with other users and affect other users' SINR, so that other users need to adjust their transmission power to suppress interference and improve their SINR, which in turn cause interference to users. In this way, infinite cycles will be generated, which will affect the global performance of the system, and it is difficult to achieve the best state. Multi-antenna anti-jamming algorithm based on artificial intelligence algorithm. The multi-antenna anti-jamming model based on artificial intelligence algorithm consists of 4 parts: agents participating in decision making, rule setting, strategies used and expected benefits. In the multi-antenna anti-jamming model based on artificial intelligence algorithm in this paper, the agents involved in decision-making are different user devices in the system. Rule setting is the multi-beam anti-jamming between multi-user devices. The set of strategies they adopt is their own transmitting power. Each agent is an independent selection strategy, and the strategies will affect each other. The expected return is defined as the net utility function, which can be expressed as equation 6. After the establishment of multi-antenna anti-jamming model based on artificial intelligence algorithm, the model needs to be trained to verify whether the model is reasonable, whether it meets the needs of multi-antenna system anti-jamming, and whether the training results can eventually converge. In this paper, particle swarm optimization algorithm is chosen to train the artificial intelligence model to verify the rationality, convergence ability, and performance of the model. Particle swarm optimization is also known as particle swarm optimization, abbreviated as PSO, which belongs to the classification of stochastic optimization algorithm. The main idea is to operate according to the fitness value of individual. Each individual is regarded as a particle without weight and volume in the n-dimension search space, and a particle without weight and value in the search space fields at a certain speed in the search space. The flight speed is dynamically adjusted by individual flight experience and group flight experience. PSO algorithm is simple in concept, is easy to implement, fast in search speed, and wide in search range, without gradient information, and with few parameters, especially its natural real number coding feature is particularly suitable for dealing with real optimization problems. At the same time, it has a profound intelligent background, which is suitable for both scientific research and engaging application. In this paper, a new anti-jamming algorithm based on artificial intelligence technology is proposed for multi-antenna system with the aid of the beamforming technology. A multi-antenna anti-jamming model based on artificial intelligence algorithm is constructed. Particle swarm optimization algorithm is used to train and verify the regionality, convergence ability, and the performance of the model. Finally, the pattern of the antenna array will form a high gain in the desired direction to enhance the desired signal, and a zero notch in the interference direction to suppress the interference signal, effectively improve the signal to interference ratio of the receiver, and then improve the system performance and increase the system capacity.
Acknowledgement. This paper is supported by the Guangdong Province Higher Vocational College and Schools, the Peer Scholar Funding Scheme, a project of the Shenzhen Science and Technology Innovation Committee, research platform, and the project of Department of Education of Guangdong Province, the key library of Longgang District, the Science and Technology Development Center of the Ministry of Education of China, and the engineering applications of the artificial interference technology library.
Research on fair scheduling algorithm of 5th-generation intelligent wireless system based on machine learning. Reporter Zhou Wu. First section is abstract. In a multi-user scheduler of 5th-generation intelligent wireless system, the users cannot get the fair transmission opportunity because of the different service packet length, transmission delay, and the channel environment of each user equipment. This paper proposes a two-stage k-means machine learning algorithm which can select the user equipment intelligently among different users' equipment to schedule, where guaranteeing the quality of service of each user's equipment. It can also take into account of fairness. Introduction. In view of the demand for broadband wireless access in the future, the EU, China, Japan, the United States, and other countries have launched the research on the demand and key technologies of the 5th-generation mobile communication system. The 5th-generation communication has become a research hotspot in the field of mobile communication at home and abroad. The 5th-generation network is an intelligent wireless network which can learn the past behavior patterns, output results, and the behavior of similar entities on the unified network or other networks, and the decision quality of the network will continue to improve. Machine learning and artificial intelligence are the best candidate technologies which can provide more powerful, complex decision-making ability for the 5th-generation intelligent wireless system. In the 5th-generation intelligent wireless system, there will be a variety of standards and user devices, such as the 5th-generation Wi-Fi or satellite communication. At the same time, the business types of user equipment with different standards and systems are also different, such as video business, live broadcast business, game business. So, what kind of machine learning algorithm can be used to intelligently select user equipment among user equipment with different delays for scheduling, which can not only ensure the service quality of each user equipment business, but also take into account the fairness, which is the research goal of this paper. In view of the demand for broadband wireless access in the future, the EU, China, Japan, the United States, and other countries have launched the research on the demand and the key technologies of the fifth generation mobile communication system. 5th generation has become a research hotspot in the field of mobile communication at home and abroad. 5th generation network is an intelligent wireless network which can learn the past behavior patterns, output results, and the behavior of similar entities on the unified network or other networks, and the decision quality of the network will continue to improve. Machine learning and artificial intelligence are the best candidate technologies which can provide more powerful, complex decision-making ability for 5th generation intelligent wireless system. In 5th generation intelligent wireless system, there will be a variety of standards and user devices such as 4th generation, 5th generation, Wi-Fi, or satellite communication. At the same time, the business types of user equipment with different standards and systems are also different, such as video business, live broadcast business, game business. So what kind of machine learning algorithm can be used to intelligently select user equipment among user equipment with different delays for scheduling, which can not only ensure the service quality of each user equipment business, but also take into account the fairness, which is a research goal of this paper. In this paper, a two-stage K-means machine learning algorithm is proposed for 5th generation intelligent wireless system, which can intelligently select user equipment among different conditions to schedule and will ensure the service quality of each user's equipment business. It can also take fairness into account. System model. The 5th generation intelligent wireless system base station uses the MMWave multi-antenna system. This paper assumes that the base station is equipped with M antennas. The service cell has a total of 8 user equipment. Each user is equipped with N antennas, and all users are evenly distributed in the cell. At the same time, it is assumed that the transmitter knows the channel information of the user. Assuming that the transmission signal of device in time slot T is, the received signal can be expressed as the equation 1, where is the emission power is the complex Gaussian random variable with the mean value of identically distributed being 0 and the variance being is a system channel matrix. As mentioned before, the 5th generation intelligent wireless system, there will be multiple standards and user equipment with multiple systems The service packet transmission delay of each user's equipment will be different, which will bring fairness to user scheduling. In this paper, a multi-user intelligent fair scheduling algorithm suitable for the 5th-generation intelligent wireless system is proposed. K-means unsupervised learning algorithm is used in machine learning algorithm. The traditional K-means algorithm is very sensitive to the selection of initial centroid, which may lead to local optimal solution. In order to overcome this problem, we improved the traditional K-means algorithm and proposed a two-stage K-means method. The selection of K value is not randomly selected, but pre-processing training is carried out at the beginning of scheduling. During a period of scheduling, the scheduling priority of user equipment is calculated according to channel environment, service data length, and average transmission delay of all user equipment to be scheduled in the system. The average transmission delay will be dynamically updated in the training stage, and the scheduling priority is sorted according to the priority. The first K user devices are selected as the initial clustering points, and the pre-processing training phase is over. Then the new user devices to be scheduled are clustered according to the normal K-means algorithm until convergence. Intelligent fair scheduling algorithm based on two-stage K-means. In order to overcome the problem that the traditional K-means algorithm is very sensitive to the selection of the initial centroid, which may cause the problem of the local optimal solution. Using the pre-processing method, the selection of K-means algorithm is not randomly selected, but the pre-processing training is carried out at the beginning of scheduling. In a period of scheduling time, the scheduling priority of user equipment is calculated according to the channel environment, service data length, and the average transmission delay of all user equipment to be scheduled in the system. Average transmission delay will be dynamically updated in the training stage, and the first K user equipment are selected as the initial clustering points, and the pre-processing training stage ends. The K initial clustering points selected after pre-processing are obtained according to the fairness criterion, which ensures that the clustering results of K-means algorithm are divided according to the fairness and avoid the local optimal solution problem caused by random selection of initial clustering points. In a multi-user scheduling of 5th-generation intelligent wireless system, due to the different service packet length, transmission delay, and channel environment of each user's device, the user cannot get the transmission opportunity fairly. This paper proposed an improvement K-means machine learning algorithm, which can intelligently select the user's device to schedule among the user's devices under different conditions, while ensuring the service quality of each user's equipment business. It can also take into account the fairness. Acknowledgements. This paper is supported by the Guangdong Province Higher Vocational Colleges and Schools, the Pearl River School Funding Scheme, a project of the Shenzhen Science and Technology Innovation Committee. research platform and project of Department of Education of Guangdong Province, a key laboratory of Longgang District, the Science and Technology Development Center of the Ministry of Education of China, and engineering applications of the Artificial Intelligence Technology Laboratory.
Okay, let's begin to talk about the research on the spectrum allocation strategy based on the Stackelberg games in the ultra-dense network. Part 1 is the introductions, and part 2 is system model of the ultra-distance network. And the part 3 is talk about the small cell clustering, and part 2 is a spectrum allocation strategy based on the Stackelberg games. And the first one is introductions. Recently, wireless communication network technology has become rapidly updated, and the user requirements of the communication service and system and the allocators of the communication network has undergone the tremendous changes. And on the one hand, the service supported by the mobile communication network are more complicated, and on the other hand, various intelligence and users purchase higher rates and higher quality wireless communication service, increasing the system complexity of the mobile communication networks, supporting more the communication users, providing more stable, faster, and more efficient data transmission has become an urgent requirement for the future development of the mobile communications. So let's talk about the part 2. You can see these figures talk about the system model of the ultra-dense network. And the ultra-distance network reduces the transmission delay by the dense deploying small basis statements to bring the transmission nodes closer to the terminal. Adding the numbers of the small base stations can increase in the system complexities, showing the better user connections and providing the user with global coverage, compared with the traditional macro-based system developments. And the ultra-distance network has the advantage of the strongly blend spectral coverage, lower the development cost, and flexible the configurations. And in response to the different usage environments, different type and the size of the small business stations has more developments and be put on the market, greatly accelerating the development of the ultra-dense network. And part 3 will talk about the small cell clustering. Clustering is to divide the complex node network tremendous into the server's network, small network cluster according to the certain criteria, and then the performance inter cluster or inter cluster resources allocation in the cluster units. Recently, we talk about the domestic and the international cluster based on the spectrum allocation management and streaming can
be divided into two categories according to the different optimizations objectives of the inferences. One is the management maximizing intro collector inferences, and another one is contract to the former. By dividing into the small same cluster, their base station very little intra-cluster inferences, so that when the same frequency resource are reduced in the cluster, no serious inference will occur. So, which is greatly improve the utilization rate of the resources. In the research of these papers, later the optimal goals is selected, and the unknown AEA is used to the cluster small base stations. So that's what we look at, like the algorithm follow can be implement according to the algorithm 1. And part 4. Part 4 we talk about the spectrum allocation strategy based on the Stackelberg games, which is talk about the Stackelberg games is non-cooperation games. So that is which some participants declare their own strategy before the other choose the strategies. When the formulating is a iterative strategy plan, the players who extract their strategies before other participants and dominate the game are called leaders. So who can impose their strategies on their players, and those who respond to the leader declare the strategy of the games are called followers. The Stackelberg games can also apply to the scenarios containing one leader and multiple followers. Therefore, there's a single leaders and multiple followers, and non-cooperation games in current solution corresponded to a situation in which the leader maximized his utility according to the failure response side, and the following play each other according to the leader's system strategy until the Nash incurrence is reached. So we talk about firstly according the principle of the reusing the spectrum as much as possible. Each small base station cluster is randomly assigned a spectrum resource block to the obtain an intentional spectrum distributions. And we talk about the small base station cluster at the same time and classified. One type of cluster is the cluster whose allocated the spectrum are not used by the another cluster, and the third type the cluster is allocated the spectrum and other small base station cluster are used at the same time. For the first type cluster, the interferences between them is small. A third type is cluster because there are another cluster members using the same frequency spectrum at the same time, and if the distance between some small base station is close, so it will cost large color inferences. So the user signal to noise ratio can be defined as the formula 6. And we can say that using the through output each cluster as utility functions. The utility functions of a small base station R in the cluster C is showing the formula 7. So the following the spectrum allocation strategy allocation based on the Stackelberg games is just showing the allocation 2, which is, you can see this picture figures shows on this. We also based on the this simulation analysis based on the ultra-dense network model consideration, the passive loss, and this picture simulation the output, the micro basis station and small basis the station cluster. The system simulate parameters are shown in the table 3. And in interfaces changes when using AEA for the clustering is shown in the figure 2. The following is the 3.5. where you can see when the Stackelberg games which the Nash increment the performance to stimulate of the micro basis station and the small basis stations cluster is showing on the figure 3.5. You can see the next you can see the performance change when the microphone based station changes its astrology in the figure 4. And the figure 5 is another following the performance of the system. And we get conclusions. This paper proposed a spectrum allocation strategy based on the Stackelberg games. In the proposed strategy, the first goal is using the AEA for clustering to minimize the intra-cluster inferences. Then let macros based on the station as layer and small base stations cluster as efforts to construct a Stackelberg games model. Optimization the spectrum allocation strategy of the small base station by the throwing Nash increment of the games. The stimulations analysis of the performance is processing from the number of the Asia output and so on. Thanks for listening. Thank you.
Thank you, Mr. Chair. Good morning, everyone. I come from Nigerian University of Aeronautics and Astronautics and currently doing some research about 3D spectral map construction. I'm honored to be here and share our research results with you. Today, my topic is UAV-assisted spectral mapping system based on Tensor definition scheme. My presentation includes 5 parts. Firstly, I will begin with a background of spectral map. With the development and wider application of integrated space and terrestrial communication networks, spectral resource is becoming scarce and scarce in both the terrestrial space and airspace. How to efficiently annotate and utilize the existing spectral resource has always been an important and urgent issue. The first step of improving spectral utilization is to coordinate the current spectral usage. However, by traditional instruments, the actual spectral data structure is toughness, and it is difficult for ordinary people to identify valid information in the spectral data. One solution is to obtain the spectral map and display the spectral usage of underlying region intuitively. Therefore, it is necessary and urgent to develop a spectral mapping system that can connect and display the spectral information in 3D space. The spectral map is also referred as radial envelopment map and radial frequency map, and the process of spectral map construction is termed as spectral cartography or spectral visualization. The main task of spectral map construction is to connect measurements values containing geographical rotation information, and then obtain the technique map through estimating the spectral information of geographical rotation where there is no measurement data. However, these existing methods are only suitable to the 2D spectral map construction. To our best knowledge, the existing literature hardly studies on constructing 3D spectral map including multidimensional spectral information. In order to fill these gaps, we develop a UAV-assisted spectral mapping system which can acquire the multidimensional spectral information including geographical rotation information and spectral power quickly and flexibly in 3D space, and model the connected multidimensional spectral data as a 3-order tensor which contains aerial spectral information with the tensor definition method to obtain the complete spectral map. Secondly, I will have a brief introduction of the proposed system. The hardware structure of proposed system is shown in Figure 1. The system is mainly composed of 4 modules: UAV platform, spatial monitoring module, data transmission module, and spectral data transmission terminal. Spectral monitoring module and data transmission module are mounted on UAV platform. UAV platform, spectral monitoring module, and data transmission module constitute the aerial part of the system, while the spectral data transmission terminal constitutes the ground part of the system. The UAV platform can provide the strong mobility in airspace for the system. The spectral monitoring module can connect the spectral information around the UAV in real time when the system runs. The data transmission module can transmit the connected spectral information and the unknown information such as geographical rotation information to the spectral data transmission terminal and receive the flight control information from the spectrum data transmission terminal. The spectrum data transmission terminal can use Tensor definition algorithm to process the connected multidimensional spectrum data, thereby realizing 3D spectrum map construction of the measurement region. Some of the system performance parameters are shown in the left table. Suddenly, I will have a brief introduction of spectrum data process algorithm in our system. As shown in Figure 2, the real-world spectrum data that the system connects in 3D space can be modeled as a three-order tensor. The x-axis, y-axis, and z-axis corresponds to the coordinate x, y, and z of the 3D space. Each element, x, I1, I2, I3, in this spectral tensor denotes the resolved signal strength in the position of the arbiter. I1, the position of the ordinate, I2, and the position of vertical coordinate, I3. In Figure 2, different colors are used in denoting different resolved signal strengths, which displays the 3D spatial distribution of RSS in a particular area. In practical applications, owing to these factors, such as the Canary environment, the number of spectral monitoring nodes, deployment notation, and measurement iterative performance has certain limitations, which makes spectral measurements can only be accompanied and limited. Therefore, retrieving the accompanied spectral data based on the limited measurements is essential for 3D spectral map construction. Given a subset omega, data in the subset omega indicate the elements corresponding to real measurement data in chi. The other elements corresponding to unknown spectrum data. Of this notation without measurements would be set to 0. The subset tensor chi omega can be defined as formula 1. Because of the no-rank property of the real-world spectrum tensor, the spectrum tensor definition for the values of unknown elements in chi can be modeled as an optimization problem, which uses the known subset to terminate the tensor data, specifically implemented as the formula 2, but it is an AP hard problem. Because the optimization problem in formula 2 is an AP hard problem, the following definition for the tensor trace normal is introduced. Under the definition, the optimization problem can be converted to the formula 4. we adopt an efficient algorithm toward high accuracy, no rot tensor definition to deal with this tensor definition problem. In Formula 4, the algorithm can work even with a small amount of samples and estimate larger missing regions of the spectrum data. This HALRTC algorithm can be summarized as follows, where rho is the penalty parameters. Also, the convergence rate of HALRTC algorithm is not the fastest. The convergence of the algorithm is guaranteed. Next, I will introduce measurements on the campaigns scenario. The measurement campaigns will carried out in journey campaigns of 19 University of Aeronautics and Astronautics. As shown in Figure 3, the measurement region is divided into 20 times 20 degrees. We operated the area part of the system to fly randomly in the measurement region and measure RSS in 20 meters, 25 meters, and 13 meters high above the ground, respectively. The frequency band between 400 and 17 MHz and 700 MHz was chosen as the observation frequency band for simplicity. It is assumed that RSS of each grid is almost consistent during the experiment. The real-world measurement data in the experiment can be modeled as a tensor whose size is 20 times 20 times 3 by corresponding the measurement rotations to the divided grids. The proposed spatial mapping system used for measurement is shown in Figure 4. After the real-world measured spectral data, see Figure 5a, is complemented by the adopted tensor definition algorithm. The 3D spectral map of the measurement region is constructed. See Figure 5b, where different tunnels denote different RSS. The effectiveness of the incomplete data estimation of the adopted tensor definition algorithm can be verified according to Figure 5. The darker the tunnel, the lower RSS of the rotation matched with the tunnel in the observation frequency band. The divided 20 times 20 times 3 3D nodes in our spectral map are the equal of the pixels of 2D spectral map. Through the contrasted spectral map, the situation of 3D spectral usage in the measurement region is displayed intuitively. Lastly, I will talk about Tatlution and future world. In this paper, the developed UAV system spectral mapping system based on Tensor recognition scheme can connect the multidimensional spectral information quickly and intelligently. In 3D space, the spectral map construction effectiveness of the system has been verified on the time-space scenario. Through the spectrum map, the invisible spectrum space can be visualized to intuitively show the usage of regional spectrum, which is convenient for discovering spectral holes and managing spectral dynamically. For the future world, we would take the fluctuation and time information into the connected spectral data and obtain the spectral map, including more information. That's all. Thank you. What questions are welcome?
Hello everyone, I'm Yi Jieluo. The title of my presentation is Secure and Reliable D2D Communications with Active Attackers, a Game-Theoretical Perspective and Machine Learning Approaches. Now let me introduce my presentation according to followed 6 paths. D2D communications is a key technology in forthcoming 5th generation Internet of Things network. Due to the limited hardware and energy storages, it is vulnerable for D2D users to be eavesdropped and jammed. Therefore, security and reliability in D2D communications should be paid more attention. Furthermore, when attackers become smarter and more attractive, it is benefit to use game theory and machine learning methods to model and analyze the interaction between D2D users and vicious attackers. According to the duplex model of smart attackers, it can be divided into 3 attacking types. Type 1. If the attacker can only switch their attacking mode between passive eavesdropping and actively jamming, it can be regarded as the half-duplex active eavesdrop, which is abbreviated as HAE. Type 2. If the attacker can launch eavesdropping and jamming strategies at the same time, and jamming actions are sufficient to eavesdrop legitimate users' confidential information, it is called the full duplex active eavesdrop, which is abbreviated as FAE. Type 3. While if the attacker can actively or smartly jamming legitimate users and maximize its distraction, it is the smart jammer, which is abbreviated as AJ or SJ. We demonstrate the anti-eavesdropping and anti-jamming scenarios in D2D communications when facing the above three types of attackers. Firstly, if there is a HAE in D2D communications, it is supposed that the HAE can jam all legitimate users, including cellular users and D2D users, and eavesdrop confidential information between D2D links in different time scales. The average secure performance of D2D users with HAE should be considered, and available countermeasure should be proposed. Then let's consider the FAE scenarios. Suppose that the FAE attack can eavesdrop D2D user and jam all legitimate users at the same time. The jamming aided eavesdropping is launched for FAE to maximize eavesdropping rates. While the self-interference of the FAE should be further considered due to the imperfect interference avoidance. When the attack becomes smarter, it can modify its power control or channel access strategies self-adaptively to destroy legitimate links and decrease transmission rates of legitimate users. For combining it, friendly jamming and cooperative relay strategies can be employed to enhance D2D communication reliability. As for HAE, its attacking mode can be switched between passively eavesdropping and actively jamming. As for FAE and AJ, they can decrease available secretion rates or transmission rates of D2D users, while adjusting their jamming power and channels. To confront smart attackers, intelligent D2D users can resort to friendly jamming or cooperatively relay strategies and make decisions on power control and channel access to improve security and reliability performance in D2D communications. Game theory is a valid mathematical tool which can analyze competition and cooperation among multi-users. It is suitable to model the countermeasure between smart attackers and legitimate users and the cooperation between cellular users and D2D users. Long cooperative game can be used to model the confrontation between smart attackers and legitimate users, and Nash equilibrium can be found and resolved by fictitious plate-based algorithm with imperfect information. Considering the hierarchical structure and asynchronous decision-making, Stackelberg game can be applied to describe the competition between cellular users and D2D users, and the Stackelberg equilibrium should be accessed by hierarchical learning algorithms such as Q-learning and stochastic learning automatic (SLA). Potential game can be used to model the cooperation among different D2D users. Nash equilibrium can be verified and achieved by best response (BR) or multi-armed banded (MAB) algorithms. In this part, we will provide some numerical results on the different attacking scenarios. In HAE scenarios, we formulate cooperative relay selection problem of cellular users and attacking mode selection problem of HAE as a non-cooperative game, and a fictitious play-based algorithm is proposed, which outperforms the nearest neighbor algorithms. Also in HAE scenario, considering the interference cost selection of the cellular user and the power control of all D2D users, the interaction between them is formulated as a Stackelberg game, and a cooperative power control algorithm based on SLA is proposed. From the figure, we can see that the algorithm we proposed has better performance than the other two algorithms. In FAE scenario, the power control problem of the cellular user or D2D user and the FAE is formulated as a multi-tier Stackelberg game. The proposed two hierarchical learning algorithms based on BR and Q-learning outperform the random selection algorithm. And in SJ scenario, considering that the smart jam can select its jamming strategy according to listening messages, the legitimate transmit and the selected relay can intelligently modify their transmission power to anti-smart jamming. The hierarchical interactions among different users is formulated as a Stackelberg game, and a hybrid learning algorithm based on Q-learning and MAB is proposed. The performance of legitimate users on the proposed algorithm, which is compared to the random selecting algorithm with different eavesdropping errors, is shown in this figure. Then we will discuss future directions of research on anti-eavesdropping and anti-jamming problems in D2D communications as follows. First, in order to confront active attackers, necessary cooperation among legitimate users is needed, not only among D2D users, but also involve cellular users. Hence, practical cooperation mechanisms and technologies of legitimate users can be further studied. Secondly, on one hand, when smart attackers work as passive eavesdroppers, they can only wiretap confidential information and hard to be discovered. On the other hand, they can do much more harm to legitimate users when they work as active jammers. Wire can be easier to be found since they need to transmit vicious jamming signals. So, there exists a trade-off of offensive and defensive of active attackers. How to apply flexible attack strategy to maximize their distraction to legitimate users and hide their positions is an open issue. Thirdly, when the number of legitimate users or smart attackers increased largely. How to model their interactions by using game theory and how to obtain the optimal equilibrium solutions will be a huge challenge. Finally, since the positions of legitimate users and smart attackers are competitive and there are no information exchanges between them, they can only make their decisions based on imperfect information for each other. The deep reinforcement learning methods are suitable for solving the problem under such situation and don't need to apply under a special game framework. Therefore, optimization with incomplete information and applications of deep reinforcement learning are worth to be studied. Finally, we give a conclusion. In this paper, we have analyzed security threats in D2D underlying cellular networks with different attacking scenarios. Based on hierarchical game framework, we expound the optimization, object description, utilities design, and the strategy selection of cellular users and D2D users. Furthermore, we have illustrated different kinds of machine learning methods, including fictitious play, MAB, Q-learning, and SLA, to optimize transmit power, relay selection, and other strategies to improve the physical security and improve anti-smart jamming performance. Finally, the further directions and challenges are discussed. That's all. Thank you.
Dear judges, I'm going to introduce this paper, Backend Development of Classroom Management System, based on .NET. The author of the paper are Jin Ying and Zhang Chunwang. The present paper can summarize as: this system is developed to provide teachers and students with high-quality communication platform and the backbone of the widespread application of the Internet. Is an independent classroom management system model applied in schools' education administration system. And the key information about this paper are curriculum system management, ASP.NET, Visual Studio, and SQLite, C#. We build this system is developed to provide teachers and students a better environment circumstance and also provide us the application of Internet. We should use this provide high-quality communication platform to build a better environment to our teachers and students about educations. This system is an independent classroom management. We should use this to control and manage our classroom circumstance. The present paper, the following is the education about introduction according to the actual need of teachers and students. A single classroom management system would have an educational administration system as the main body. It is established under the environment of front-end interface, and the database is created. The whole management system is designed for purpose of safety, stable, convenience, and so on. We also use the implementation of this management system, take ASP.NET as a main body. We usually use C# language, Visual Studio as the core development tool, and Data Adapter as a means to connect to the database for development. Administrators, students, teachers as the core for the connection of finished school with students in system. The administrator and teacher for students to upload information and management functions. Purpose lies in the use of classroom management system to improve students' learning efficiency, strengthen the supervision of teachers to the students. For teachers and students, set up a bridge of communication before. The importance of our paper and our creator want to set up a bridge to give a better circumstance for our students and teachers in our educational environment, according to actual need of students. Teachers and students all need a system to strengthen and grow up our tools about education from our class. A single classroom management system have an educational administration system as the main body is established under the environment of front-end interface and the database. The following is system design. The main purpose of classroom management system is to realize the different rules, permissions, and real-time management of various objects in the system. The classroom management system model is managed uniformly by main model. The original education system of the login, different operations are implied. The whole classroom management system are independent of each other, but all the data in the backend comes from the same database, and the data of each rule model is interoperable, which facilitates the maintenance and optimization of system in the later period. The following figure 1 shows the functional models of system. The class management system is a core part of our system design, and the teacher and sister and students and administration is the important part of our system design part. Teacher and including class selections, class management, class attendance, and class report or record. Teacher end means for teacher and student end, including password modification, class performance query, and attendance record query. At last, administrator including information browser and query. We should control the teacher and students and administrator as the important part of our system design. The following is database design of classroom management system. The first part of this important group is that database design. System database design directly decided the overall efficiency of the system. In the design of database of time must be difficult specific naming, classification, and separate. The data void with more date classification is not clear. Repeat after, otherwise it will increasing the work pressure of the developer. After completion of system development, maintains workload, also increasing substantially, reduce the performance of system and development. The design of database should also be a comprehensive analysis of performance problems to avoid system crash, field, and other security risks, but also conductive to save resources and costs. From this part, database design is an efficiency design of database, and it's including classification, separate date to avoid when more data classification is not clear. Repeat after, otherwise it will increasing the work pressure. After that, the maintenance workload also increasing substantial, reduce the performance of system and develop. The design of the system should be a comprehensive analysis to avoid system crash. And we also from this system can achieve a lot of things. For example, we can use the design of database to be a comprehensive analysis to avoid system crash or system failure and other security risks, but also conductive to save resource and cost. All about this creation can make our system more powerful and more creational. Next part is database log design diagram. The logic of database is usually represented by design drawing, which is mainly composed of entity, attribute, and relationship. Entities are objects such as teachers, students. Attributes are attributes that are owned by individual entities, such as student names, the course, and so on. Relationships are the connection between entities. Figure 2 shows the ER design drawing for the logic of database. The database for this system is pretty important. Though owned by individual entities such as student names, secures, and so on, such as class, grades, and some information about students and their class. Relationships are the connection between entities. Figure 2 shows that. The following is system debugging. Hardware debug. Open Visual Studio. Lock the system anti-grabbing fields. And the Google Chrome browser by default will display the technology front page. Enter the classroom management system. Click on all returnable items and dynamically operate the front page. Click on the front page of front-end classroom management system to enter any class and select class 2 or grade 3 for the test. After entering the classroom management interface, of the class management interface of students was randomly selected. This student was selected and graded. During the test, select easy to pass, emotional stability, and quit of the class from the phrase list, and record the time as shown in figure 3 below. In the list of to be improved, select distracted in class. disruptive in class and recording the time, as shown in Figure 4 below. And the classroom attendance system, select a student at random, select number 6 for the task, as shown in the Figure 5. Check the free screen of scoring chart, as shown in Figure 6 below. The to-be-improved interface of scoring record table is shown in Figure 7, and the tendency information of score, we can see it in Figure 8. Check to see if the previous action is displayed in the various table as required. Open Visual Studio and check out front page of front-end classroom management system. In the class tool directory, the classroom management interface of the class management is a teacher or a student, as shown in that. The following is conclusions. In the preliminary test, the dynamic jump of front page could not be completed. After checking, it was found that the name of backend interface was entered incorrectly. Now it has been modified and the normal dynamic jump can be completed. Achieving the expected effects simulate students' classroom management, attendance rating, and other operation of system through real data, and complete the expected requirement for the system. In the primary test, we build a system, use Visual Studio and C# language to build front page could not be completed. After checking, it was found that the name of backend interface was entered incorrectly. Now, it has been modified and normal dynamic jump can be completed. Achieving the expected effect, simulate system classroom manage. We build this system about our circumstance of educational to students and teachers. Is pretty important for the global environment education. You can use this system through real data and our experiments and trial, or from real data from our normal life, and complete the expected requirement of system. It was found that the name of backend interface was student classroom management, attendance rating, and other operations of system through real data. In this paper, we also build a better system from internet to achieve more creation and function. We want to use this special system to build a better environment about our education for students and teachers.
System of students' comprehensive ability software performance test and analysis. Structure. This system is mainly for classroom management system, including school situation analysis, event management, school fields, daily tests. Teachers upload information, students view information in the Visual Studio 2015 development environment.
using C language, object-oriented programming using framework 4.5 SQL database development in the software test after coding. The student's classroom management system is more and more perfect. Keywords: software testing, classroom management, C language, best 2015. Introduction. With the continuous development of science and technology, the position and function of computer and computer network are increasingly prominent. Network classroom management should become a very important teaching network classroom management system is more and more attention. This paper mainly studies the application and promotion of classroom management system to solve the problem of multi-platform heterogeneous data interpretation, the content of student attendance, planning the teaching evaluation is completed through multi-system. By studying the forms of classroom management score report, attendance report, student information, and related technology in the network classroom system. The original multimedia teaching technology is extended, and the classroom performance of students is digitized by combining the traditional teaching mode. Inspect and test the entire project to ensure the feasibility and normal operation of the program, including data testing of each model and each function upon completion of the classroom management development through the automatic tests, including black box testing and white box testing, to shorten the test cycle. Software development can make the product faster finish. Automatic testing is more efficient. Make full use of hardware resources and save human resources with that. Test cost also can enhance the stability and reliability test, improve the accuracy of software testing and accuracy, increase software stress. Is relatively easy to make the software test tools work. The main enemies. Students' requirements for system function mainly include management and modification of personal accounts and passwords, inquiry of attendance records, inquiry of class results, rising from teachers or situation requiring improvement, class records, attendance summary reports, and other functions. The administrators have information management, browsing, and other roles, includes records, teacher-student operations, including checks for data additions and deletions from the perspective of user management and classroom management. User management mainly includes viewing and modifying the information of teachers and students, while classroom management includes adding dignity, changing, tracking, and the attendance reports of student data, student scores, and other information. 3. System software design and attributes. 3.1 Modal design. The user in the front end enters in the account password through retrieval and regular experience to determine whether the user input conforms to the rules, including HTML and 8 in accordance with the input, and to prevent SQL injection, not of the above, under the precondition of updating by the rules of Ajax. After click the button after linking to input option of the info value, the introduction of the value, the backend through user name to query the user list. If there is no query to the data, the user does not exist. The query to the later, the user to enter the password, and query to the password string compression through the conditions statements. If equal, login is success. If not, the password is wrong. The administrator login is parallel and independent models of student login and teacher login. The specific login name is similar to the system login name, which can take the input level from the front end and send it to the back end using Ajax for judgment and prompting. Information management is mainly the operation of the teacher's students' class performance for a particular class. The students of class information ratings reviews view-in comments interface options, then click on the submit button. Because the information has a null level, but after viewing the very regular experience to determine whether the input, the legal input HTML code and SQL injection legally in the same way through the just basic building is passed to the backend data through the SQL statement to insert data into a specific table and insert specific information. Class management is mainly to classify the majors and class of secondary majors in order to better index students and .2 database design. This project is mainly divided into the user table, teacher table, the table class, students information table, classifying of secondary school, professional classification, components information table, users table and students watch teachers and administrators table is mainly responsible for user logic, including class table and classification table and student ID. Student table is associated with secondary school and the professional classification by operating the class table. The teacher adds and modifies the data of students' classroom performance
Here is the diagram. Mean user table is divided into 3 categories, including teachers, students, administrators, including the user table by teacher student ID. The details of the corresponding table query student ID or drop number and password. The login page by getting the from and account password after compared with back-end query and database account password. If correct, the login is successful to enter the main page. The administrator is the identified teacher number. The administrator can act as the administrator as well as the teacher, adding, deleting, modifying, and tracking classroom records. The student only has the right to view classroom records and has no right to modify them, but the student can modify their own general information. The student table is the specific information of students, which is associated with other tables to obtain students' classroom performance and class rating, mainly including student ID, username, gender, student number, class, and corresponding major and secondary college of the class. And finally, the mobile phone number. The teacher table is similar to the student table, but the only difference between teachers and students is that the authority is higher than that of students. The teacher table identifier is the administrator, and their relationship is that the administrator's authority is greater than that of teachers and students. To protect data and prevent data from misoperation. The class table is similar to the class schedule, which records the current classroom, and class attendance class. Each period has the teacher in charge of the current classroom. For the convenience of classification, the class table includes the class ID, class classification, teacher's classroom, class attendance class, and the cell phone number of the teacher or person in charge. System depth debugging for front-end class management homepage test. The implementation method of homepage is relatively simple, mainly presenting class information. Click enter the corresponding class management interface, which contains class information and the name of the class teacher. The test is here. Click the corresponding class on the homepage and enter the class management interface, which is divided into 6 functions, including class guiding, class attendance, class report, rhythm selection, and time as shown in the figure below. Conclusions. The test should be designed for a specific purpose and then tested for important aspects of one or more functions. Key test cases that are executed multiple times can be automated to properly evaluate the development and
the swing of automatic test scopes. In general, manual testing can replace automatic testing of any type and function. Automatic testing is difficult to implement in situations such as multi-user concurrency and broader user, while the use of testing tools can improve the quality and efficiency of testing. The successful implementation of automatic testing must follow the concept of systematic structures and progressive testing.
Dear Judge, I'm going to introduce this paper, Design and Implementation of Multimedia Resource Management System. The author of this paper is Liu Qun, Division of Science and Technology, Harbin University. The present paper can be summarized as Multimedia Resource Management System is a new media product based on the last-wave supervision contact platform based on years of accurate user experiments we have carried out in deep transformations and made many functional improvements and innovations on the premise of reading the traditional media functions. The core of this paper is the multimedia, HAVE, resource management, retrieve. From this paper, we introduce a multimedia resource management system, and it's a new media product based on last-wave supervision contact platform based on years of actually using experience. And we can use this management system carry out in deep transformation and make many functional improvements and innovation on promise of retraining the traditional media function. The following is introduction as the connect of media assets in the field of radio and television and internet multimedia field. Distribution channel increasingly diverse, and for its own raising consumer demand, television stations connect creation, trader and individual creators. Business management process also facing increasingly diverse field. Urgently need a medium resource management platform to meet the different needs. At the same time, the developed trend of closed service in recent years is obvious to all. The vigorous development of hardware supporting and network service provides a solid function for closed service. The following is system design. The Multimedia Resource Management System based USES, the HAVE platform. HAVE is a based infrastructure service platform that provides data engines, computing engines, business engines, and data sets access interfaces to meet the growing demand for data in industry. Based on the HAP platform, Multimedia resource management system provides a variety of application-level toolsets to meet its storage management, business process, connect management, and using requirements. From Figure 2 is Media System Deployment Diagram. In System 3, the following is system implementation. The proto of the multimedia resource management system media capital system can display the push poster content and get a ranking according to aggregation analysis of various big data in system. You can also make content recommendation based on the user's behavior and record the user's browsing history. Next comes the system about retrieval as a media product. Multimedia resource management system serves as a basic and important function based on the traditional media product and the technologic advantage of HAVE. Multimedia resource management system greatly provide retrieve processing and retrieve efficiency, full text search, advanced search, conditional filter, and secondary search not only meet users' various search habits, but also can be combined in variety of ways to further the improved actuality of search. The first point, full text retrieval, support information retrieval of most added field, information combination retrieval of different catalogs, layers, support directly label retrieval, support logical retrieval. From the Figure 2, full text search, advanced search. In this part, using can add more fields as needed to check, and only the results containing this information in the set field can be retrieved. The next is permission control, flexible configuration of system function model to meet the need of different users. User permission configuration. Different users can have different permissions configurations. The next is function permission setting. Each function permission setting, user with permission, cooperation foundation visible available. From Figure 4, we can see that function permission setting, catalogs, copyright management, download, entity delete, entity edit, export, statistic, web import, field exchange, document introduction and datasite introduction, lightweight web page upload, single or multiple folder upload, and upload made editing, but also supports batch editing. Figure 5 is field introduction and datasite introduction. Document review, wherein and fairly checking function can be enabled for context store in the media library. In this way, users can check the content and the quality of storage before the storage. Quality audit, including black field, static frame, silent, and other checked. The results of background automatic technologic audit will be displayed on the interface, and user can directly check to view. Content including connect logically checked. User can directly play view. Outbound audit, according to figured outbound strategy. Documents conform to the strategy will have configured strategy when they leave the warehouse. After approval, the outbound task will be successful and file will be sent to destination address. Figure 5 is document review and conclusion. The following is that Cellular Multimedia Resource Management System solution comes into being, an enterprise-class comprehension code service system based on Hive content platform, which can realize private code, public code, and hybrid cloud solutions. Cellular Multimedia Resource Management System to mass material storage and sharing as content, provide multi-system material management, sharing and release function to achieve more efficiency fast, humanized media content management at the same time. Cloud service solution can greatly reduce optional cost and help users face new challenge in the evolving media landscape. Cellular Multimedia Resource Management System can do a lot of things. It is an enterprise-class comprehensive cloud service system and is based on Hive content platform. This can realize private cloud, public cloud, and hybrid cloud solutions. This system to mass material storage and sharing as the center provide multi-system management achieve interaction sharing and release function, and we can use this to achieve more efficiency fast. Humanized media content management at the same time. Code service solution can greatly reduce operational cost and help user face new challenge in the evolving media landscape. Cellular Resource Management System solution is including public cloud and hybrid cloud solutions. This system can mass material storage and sharing as center, provide multi-system material system, and this also can sharing and release functions to achieve more effectiveness fast. Media content management. It can manage some media resource such as video, audio, or other pictures, and also can reduce operating cost and help users face new challenge. It also can help user to work a lot of important questions and problems. This maritime material system can storage and sharing is Center provide multi-system material and humanized media content management. It can make our video resource have a better management, and we can easily to find it from some folder. An enterprise-class comprehensive cloud service system is a Hive content platform, which can realize private cloud, public cloud, and hybrid cloud. This cloud can help us to storage some resource, including video resource or audio resource. From this paper, we build a system named Solvay Multimedia Resource Management. From this paper, we can achieve some creation from this system, such as build some clouds, including public clouds and hybrid clouds. And this grid can help our user to build more movies, and when we want to enjoy some video, we can store it in our management system. And if we want to see it some years ago, we can find it easily. This management system, we can sharing as the center provides multi-system material management, achieve and sharing release function to achieve more efficiency, and content management. At the same time, cloud service solution can greatly reduce optional cost and help user face more challenge and face some challenge in the evolving media landscape. From Figure 5, we can see that document review. In this picture, there are several audio resources, such as ZY 2017, and this picture resource is from Guang'an. And below, a lot of picture resource, we can restore it in our cloud.
This paper's name is Smart Beamformer based on artificial intelligence. Reporter is Zhou Wu.
Introduction. The smart antenna can focus the transmitted signal only on the desired user, making special noise in a direction to the undesired users. Moreover, it can adjust its transmission weight according to condition change of users. Game theory in artificial intelligence algorithm has become popular recently to analyze distributed problems. A game-theoretic framework for greedy interference avoidance algorithm is presented in This model provides insight into development of algorithms that are fairer than the greedy interference avoidance algorithms. A distributed power control algorithm for wireless data system is proposed in the QoS wireless terminal receivers is referred to as the utility and distribute power control, where users can maximize their utilities is a non-cooperative power control game.
In this paper, we present a decentralized smart beamformer based on game theory. The main contributions of this paper are: 1. Beamformer game model is constructed and the transmission weights adjustment of different users are described as multi-user game. Second, the existence and uniqueness of the next equilibrium in the decentralized active beamformer based on game theory are proved. Third, convergent transmission with update algorithm is designed.
Let me introduce system model of this paper. A multiple input, multiple output MIMO system using transmitter and receive antenna is characterized by the equation 1, y equal to hvx at noise, where y is the dimensional receive vector of user. We assume that totally users are distributed in the system is the dimension white causing noise vector, describes the channel matrix and the elements of are modeled as zero mean complex Gaussian random variables and its transmission weight of user. We support and the resulting received SINR. That means signal to interference and noise ratio of user is the equation 2. Where its transmission weight of user and is the covariance of channel, and the transmission weight vectors can be split up into the equation 3, where and are the transmit power and the orientation of the transmission weight vector respectively. In this letter, we support that is known by the transmitter. So, the SINR of user is a function of transmit power. Smarter beamformer based on game theory. Game theory can be used to predict the outcome of this interactions
and identify optimal chargers and deleterious ones. The fundamental component of game theory is the notion of a game, expressed in normal form as where is a particular game is a finite set of players, is the set of the action available to players, and is the set of pure utility. In this letter, we defined as the equation for where is the whole utility function and represents the function of the SINR of user, and is the cost function and a constant, is an adjustable parameter and shows goodness degree of which is set by the same value for all users, is the cost factor and defines the user's cost when it is interfered by other users. When we consider a best response dynamics defined below, the equation 5, now we suppose K equal to U RLU. So the SINR of user in the equation 2 can also be expressed as equation 6. Differentiating the equation 5 is we can get equation 7. Through the equation 7, transmit power can be expressed as equation 8. From the equation 8, we can find that the transmit power of user includes the interference of other users. So the transmit power of different users will affect each other. Next, we will demonstrate that the power allocation for different users can converge to a Nash equilibrium at the NE. Given the power levels of other players, no users can improve its utility level by making individual changes in this power. In reference 3, the theory of existence and uniqueness of NE is presented. According to these theorems, we will prove the existence and uniqueness of NE of the proposed algorithm. Decentralized smart beamforming algorithm based on game theory is proposed deconstruct beamforming game theory game algorithm, mathematics model, transmission weights adjustment of different users are described as multi-users game, like distance and uniqueness of the next equilibrium in a smart beamforming algorithm based on game theory are improved. Convergent transmission weights update algorithm is designed.
Acknowledgement. This paper is supported by the Guangdong Province Higher Vocational Colleges and Schools, the Pearl River Scholar Funding Scheme 2016, a project of the Shenzhen Science and Technology Innovation Committee JCYJ 20171145222834 JCYJ 201606081512399996 research platform and project of Department of Education of Guangdong Province 2019 GGCZX009. The key library of Longgang District, the Science and Technology Development Center of the Ministry of Education of China, and in engineering applications of the Artificial Intelligence Technology Laboratory PT 201701.
Hello everyone, I come from Shenzhen Institute of Information Technology. My presentation topic is Attention-Based Bidirectional Long Short-Term Memory Neural Network for Short Answer Scoring. Now let's go to the specific content. My contents include 5 parts. Now let's go to part 1. Part 1 is Introduction. The short answer examinations are considered as an essential part in the educational processes. It can help students to check the mastery of a problem. But now, there are a lot of short answers which are produced by students need to be examined. It is a large workload for human answer writers. To solve a above problem, many answer examination computational approaches have been invented. These approaches are regarded as a machine learning approach, such as classification or linear regression. Most of machine learning approaches make use of various statistic features, such as total words number, different words number, word spelling errors, average of words syllables, sentences frequency, essays length, tone frequency, inverse document frequency, and so on. But now, the most effective approach to solve the problems of short answer examinations is the technology of deep neural network. And the DNN has achieved remarkable advances in the field of automatic answer scoring. In a sense, answer scoring is like answer classification. In answer classification field, most of the studies are focused on how to learn word vector representations by neural language models and how to classify the answers based on the learned word vectors. Therefore, the basic of answer classification is find a highly efficient word vector representations. At present, the most popular word vector representation models are word-to-vector, C and W, GLOVE, and so on. In this paper, we propose a novel DNN architecture for short answer scoring. This new architecture is an enhanced BISTM by using Google Word Vector and attention mechanism, referred to as attention-based BISTM neural network with GWA as the input layer. We call it BISTM. Part 2 is related work. The AAS has been pushed into a new stage by the invention of DNN. In recent years, there are many researchers have proposed many approaches to improve DNN. John et al. Proposed a deep belief networks to tackle the task of AAS. Their experimental results show that DBN is the best model than other models, which mentioned in the article. Xiang et al. apply a temporal convolutional network to various large-scale datasets, including ontology classification, sentiment analysis, and text categorization. Their model can achieve astonishing performance without the knowledge of words, phrases, sentences, and any other syntactic or semantic. While EAI proposed a BISTM to achieve the efficient AAS for Punjabi language. Soya K. EAI compared some DNA techniques for AAS task. The results show that BRT performs better than CN and ASTM. Part 3 is automatic short answer scoring model. The designed novel architecture is named attention-based BISTM with GWA as the input layer. We call it GA-BISTM. The model consists of 4 components: word embedding layer, BISTM layer, attention layer, as well as softmax layer. The word embedding layer converts words of answer to word vectors and takes them as the input of the BISTM layer. In natural language processing field, how to represent words of text is important. Usually, there are 2 ways to represent words: one-hot representation and distributed representation. Compared to one-hot representation, distributed representation of word embedding not only reflects the characteristics of low dimension, but also reflects the orderly relationship between words of text. In this paper, we use the word vector, which trained on Google News dataset in experiments. The BISTM layer accesses the contextual features. The contextual features extraction capability of BISTM is more powerful than LSTM because the BISTM can access to both history and future of the given time frame throughout backward and forward layers together. The attention layer has been used to pay more attention to information units which strongly related to the score of the answer, because AM can focus on the important words to reduce the impact of unimportant words. In this paper, we provide an AM layer after the output of BISTM to learn a weight combination of hidden states across our time steps and produce a global feature vector. The softmax layer is to classify the output of the AM layer. Part 4 is experiment. Dataset. In this paper, the used dataset is come from automated student assessment prize. We can call it ASAP. The dataset consists of 10 prompts as listed in table. There are a total of 17,207 training answers. The prompts scored on either a scale of 0 to 2 or 0 to 3. There are no released labeled test data from the ASAP computation. Therefore, we just divided the released dataset into 3 parts: 16% for training set, 20% for the validation set, and 20% for the test set. Evaluation metrics. In our experiment, we use quadratic weighted kappa to evaluate our results. At the same, the QW kappa is also used in ASAP computation. The QW kappa is an index to measure the agreement between the raters. The result of QW kappa equal to 0 when the scores of raters are identical. The result of QW kappa equal to 0 when the scores of raters are totally inconsistent. Parameter settings. We adopt the OFDM optimizer as the optimization algorithm. The best hyperparameters obtained through multiple experiments are shown in table. The initial learning rate is set to 0.01. The learning rate is reduced by 0.05 times once every one epoch. The word embedding we use GWV, and the dimension is 300. The hidden units of BIRSTM layer is 128. The dropout rate is 0.5. Results. We use several baseline methods as the benchmarks. The results of those baseline models are listed in table. The experiment results are evaluated by QWK. The font, which is bold, presents the best experiment results as the table showing. Our approaches, including our approach, are deep neural network approaches. In table, we can find that our approach of GA-BIRSTM has achieved the best result than other approaches on the average QWK value. Among the 4 approaches mentioned in table, we approach outperforms other baseline models on all prompts except prompt 4, prompt 7, prompt 8, and prompt 9. Part 5 is conclusions. In this paper, we augmented the input by using GWV as the representation of the contextual information of answers. It is expected to learn more key information of answers by using BIRSTM, which can in any point in time to preserve information from both past and future by combining 2 hidden states. The themes of some prompts of ASAP dataset are clear. To this kind of short answers, the technique of AM is an efficient choice to extract the key themes information. Therefore, word vector, neural network architecture, and the design of classifier are the key point for AAS. Our experiment results indicate that our model can score in short answers more accurately in terms of the quality of the results. Meanwhile, GA-BIRSTM demonstrates that our model is more effective and efficient than other baseline methods in most cases. Thank you for your listening.
Hello, my name is Dean Lohr, and I'm from Shenzhen Institute of Information Technology in China. Today I'm going to present my paper, Automatic Scoring or L2 English Speech based on ENN acoustic models with Lattice-Free MMI. This study is the joint work with Minxiang Guan and Linzhong Xia. First, this is the outline of my presentation. First, I'm going to introduce the background of the study, and then I'm going to introduce the automatic scoring methods for L2 speech. First, I'm going to explain the goodness of pronunciation, or so-called GOP score. And then I'm going to explain the DNN, or the Deep Neural Network-based GOP implementation methods. And finally, I'm going to introduce our proposed automatic scoring based on lattice-free maximum mutual information, or MMI. First, I'm going to explain what the lattice-free MMI acoustic modeling is, and then the forward-backward algorithm used for this lattice-free MMI acoustic modeling. And finally, the GOP score we proposed that is based on lattice-free MMI. And then the experiments. First, the speech data and reference scores we use for our experiments. And then the acoustic models. And then the experimental results and analysis. Finally, the conclusion. First, the background. English speaking tests have become mandatory in college and senior high school entrance examinations in many cities in China. Most of these tests are assessed manually. However, it costs a lot of time and effort for human experts to assess those L2 speech, and it's very difficult to recruit enough qualified experts. So, the recent advances in automatic scoring based on ASR, and these technologies could be a solution to those problems. And actually, it has been used in high-stakes English tests as reported by our previous studies published in 2018. And we have attained comparable performances with human raters. However, still many educators remain skeptical about the technology, mostly about the liability of the automatic scorings, because there are many factors that can affect the performance of the automatic scoring methods, including environmental noises, recording devices, and speaker characteristics. So the objective of the study try to provide state-of-the-art technologies and their applications in pronunciation, evaluation for high-stakes English tests. We try to improve automatic scorings based on DNN with lattice-free MMI acoustic modeling. We implement two kinds of GOP scoring based on the lattice-free MMI, and we try to find out if they can outperform the previous state-of-the-art automatic scoring methods. First, I'm going to explain the traditional goodness of pronunciation algorithm, or so-called GOP algorithm. The classic GOP score definition is given by equation 1 and 2, where the P of phoneme P given O is the posterior probability that the speaker pronounced the phoneme P given speech observation O. Q is the full set of phonemes. So when implementing these algorithms using the traditional GM and HNN acoustic models, usually the numerators of equation 2 is a phone likelihood calculated through a phone level HNN force alignment, and the denominators is the likelihood of the phone name recognized through a phone loop network. As the DNN HNN hybrid models became very popular in acoustic in automatic speech recognition, and the DNN-based GOP have been implemented using the average frame posteriors with the output of DNN as shown in equation 3. So the PST given OT is the frame or state level posterior output of a DNN, and OT is the feature observation at time t. And for TS and TE are the start and end time of phoneme P, which can be calculated through force alignment. So we denote this kind of this implementation of GOP as GOP1 and as a baseline. And in our previous study, we introduced another implementation of GOP based on DNN models, which we consider is more noise robust. So for the classic definition of GOP as shown in equation 1 and 2, we can use equation 4 and equation 5 as calculated from the DNN HNN modeling, which the capital S is the set of all states or sentence, and PSD are the state level priors calculated during the DNA HNN training. So if we applied equation 4 and equation 5 to equation 2, we can implement it a better GOP algorithm, and that is reported in our previous study. We used this method as another baseline, and we denoted it as GOP2. So we had two baselines, GOP1 and GOP2. And I'm going to introduce the acoustic modeling based on maximum mutual information, or the MMI. The traditional objective function for estimating HNN parameters, even for GMN HMN or for the DNN HNN in speech recognition, is defined as in equation 6 and equation 7. But as an alternative, maximum mutual information, or MMI, is a discriminator objective function which aims to maximize the probability of the reference transcription, while minimize the probability of all other transcriptions, as shown in equation 8 and equation 9. If we defined the state occupancy probability as in equation 13, so our gradient equation becomes the equation 14, then equation 15. So here the gamma RTS is the general state postulate and computed by forward-backward algorithm, which I'll explain later, with the denominator graph of the lattice-free MMI models. And the log of the p theta of OT given ST can be obtained through neural network output. So for the gamma RT or S given WR can be calculated with numerator graph of lattice-free MMI models. Povey, etc. use MMI training for lattice-free MMI models use a full denominator graph by adopting techniques as using a phone language model instead of a word language model. For the denominator graph, and most importantly, performing the denominator computation on GPU hardware. Now I'm going to explain the forward-backward algorithm. First, forward probability. The FB algorithm is widely used to calculate the state occupancy probability for HNN parameter estimation. The forward probability of FB algorithm is the joint probability of observing first t speech vectors and being in state J at time t, given some model M, as shown in equation 16. It can be efficiently calculated by the following recursion, as shown in 17, where Aij is the transition probability from state I to J, and Bj of OT is the probability density of speech vector OT being generated from state J, and N is the total number of states. So the initial condition for the above recursion are alpha 1 equal 1, as shown in equation 18. And then for alpha J1 equals alpha 1J, A1J, which is transition probability, and the Bj of O1, as shown in equation 19. For the J between 1 and N, and the final condition is given by alpha NT equals, as shown in equation 20. For the definition of forward probabilities, we can obtain the total likelihood as shown in equation 21. For the backward probability, it's defined as shown in equation 22, and can be computed with the following recursion as shown in 23. The initial condition is given by equation 24, and for J between 1 and N, the final condition is given by equation 25. State occupation probability. By the definition of the forward and backward probability, if we take the product of the two, we can yield the equation 26. the state occupation probability in equation 13 becomes equation 27 and then 28. Substituting equation 26 and 21 into equation 28 gives the equation 29. This demonstrates the state occupation probability used for lattice-free MMI training can be computed through forward-backward algorithm with numerator and denominator graphs. So now we'll introduce the first implementation of our GOP score based on lattice-free MMI. We use word condition probability at frame level through force alignment to substitute the DNN output as introduced in equation 2. Coupled with the non-linearity characteristics of DNN output, condition probability P theta T of S given OR and W incorporates transition probability Aij from I to J and the sequential information W pertaining to transcription, which is very suitable for pronunciation assessment or reading aloud. Therefore, our first implementation of LF or lattice-free MMI GOP score is given by as shown in equation 30, where W can be viewed as the word sequence from transcription. We call this implementation of GOP as GOP weight, because the word sequence condition probability can be interpreted as state posterior weights during force alignment. And then our second implementation of lattice-free MMI-based GOP is defined as equation 31. We call it GOP FB because we calculated the GOP FB through forward-backward algorithm with denominator graph or lattice-free MMI acoustic model. As the gamma RTS in equation 31st is independent of specific transcription of given utterance, GOP FB can be used for general pronunciation evaluation purposes, not only for reading aloud, but also other more open tasks, such as retelling or spontaneous conversations. Finally, the experiments. The speech data we use are the recording data of the English-speaking test in Shenzhen High School Unified Examination. It's from a repeating a 1 minute long video clip. The students are required to watch and listen to a video clip with English subtitles twice, and then they are required to read aloud subtitles on the video. Altogether, there are 600 utterances, including 300 males and 300 female learners. For the reference scores, 3 experts were recruited to manually evaluate students' speech and gave an overall proficiency score for each utterance. For acoustic models, we used the CalDi toolkit, and with the hybrid DNA models with the HNN3, the NNNet3 package. For the training data, we use Librestream corpus, which contains 960 speakers. Specifically, we trained the monophone and triphone based on the NFCCs with delta and double deltas, We then train 4-dimensional features transformed with LD8 and MLT. We train 6-layer time-delayed feed-forward neural networks with pnorm, which p equals 2, and input and output dimensions set to 3000 and 250, respectively. We train with an initial learning rate set to 0.005, which was reduced exponentially to 1/10 of the original rate over 8 apertures. The lattice-free MMI setups are the same as Powys' paper. Here are the experimental results. From Table 2, we can see that compared with the two baselines, GOP1 and GOP2, the correlation between automatic scores and reference scores of the GOP weight, the proposed method, and also another proposed method, GOP-FB, outperformed the traditional GOP1 and our previous proposed noise-robust GOP2 significantly. The GOP weight yields the best result of 0.82, and GOP-FB also shows good performance of 0.81. And then we investigate the correlations between automatic scores and reference scores with different levels of proficiencies. We divided the learners as beginners, intermediate, and advanced level. And for each group, as we can see in Table 2, GOP weight and GOP-FB, the two proposed methods, outperform GOP1 and GOP2. For the beginners, GOP-FB shows best result of 0.65. And for intermediate and advanced learners, GOP weight shows the best results. For all the group of the learners with different proficiency level, GOP weight and GOP-FB outperforms the traditional GOP1 and our previous state-of-the-art GOP implementation, GOP2. So finally, the conclusion. We have proposed two novel implementations of goodness of pronunciation, or GOP, based on lattice-free MMI to improve automatic scoring of L2 English speech. Experimental results shows that by incorporating sequential information of speech, significant improvements have been found over the conventional GAP-based automatic scoring methods based on DNN, HNN acoustic models within the maximum likelihood criterion. Thank you very much for your kind attention.
Front-end development of classroom management system based on H5. Abstractor. This system is a classroom management system envisaged by convenient educators. It develops some functions that are often used in the classroom, such as classroom attendance and timing, and timing, which are all the functions we have been developed on this system. Keywords: HTML5, education, classroom management, CSS, JavaScript. Introduction: HTML5 Web Front-End Development, also known as HTML White Page Development. HTML5 is the core language of the web at present. It has enhanced the performance of web page and added local database and other functions. The front end of the web page mainly designs the layout and planning of the page, with the design driving as the ontology, and then writes the page code on this basis, so that users can get the user experience in a broad sense. HTML5 is a technical language based on HTML, CSS, and JavaScript. HTML5 is now the mainstream web development technology. It has excellent semantic taste and can be combined with CSS3 to form the display web for an unprocessed data estate. Among the most common browsers used today, I9 and above, Firefox, Google, and browsers developed by IE of the current kernel or Sport HTML5. The development tool used in this project is Visual Studio Code. The tool used in the development of this is a software named Visual Studio Code. Visual Studio Code is a free, open source, cross-platform editor released by Microsoft. Although it is a lightweight editor, it has powerful functions and is applicable to Windows, Mac OS, Linux, and other operating systems. In addition to the languages used in this project, it supports many other languages, such as C, Java, Python, PHP, C language, and so on. The isolation of the plugin process from the main process, the delay loading of the plugin, and of the text buffer can improve the coding and editing speed of large fields and reduce the memorized utilization. In addition, there are a lot of indentation packages available for download within the software, which can be used immediately after downloading without restarting the software. It also features highlighting, intelligent code completion, code checking, and validation, custom hotkeys, bracket marking, machine code fragments, system design. This system needs to have user functions, but is only a reference without detailed high functions. It is mainly the reformers with burden and used by teachers without the use of all levels. In addition, most of the functions are actually usable, including class selection, rhythm selection, name calling, guidance, timer, record management. These features are displayed by clicking on certain sections. The functional framework is stored in the figure. The functions shown in the figure above are the functional requirements in this stage by this system for classroom management. A major classroom management system should have helpful missions for classroom management and help users to manage and make statistics for each lesson. Implementation of major functions. 3.1 Interface design. Have detailed contact information. The main colors of the site are emerald, green, and white, and the ground colors are white and black. As a membership management system, the principle of user design of the website is to minimize the amount of other information space associated with the page, so that the user sees only what the content requires, rather than what is attached to it. The layout of a web page should first be simple and clear. That is, the most information can be experienced with the viewer's screen elements. Each page on the same site has a largely consistent page layout. In this way, users can be familiar with the use of each page when using the website without the strangeness of each page, which is a very important part of the website design. Website website decoration style. The website menu uses SBS as the main color. Use white as the main color. The decoration uses emerald green as a color, so that the main white will not appear to green in the unique style of white. At the same time, the site uses CSS animation and JavaScript effects. Also make the site has a vivid three-dimensional to array users of the site products boring mode, because this website is based on a system born from an existing website. This website only has some available links, such as the class page on the sub page. the login page to which the login page is redirected, and the homepage of the original website returned by the return button. The problem website map for report, feedback, and suggestions at the button are all set out. There is no access page from its development and implementation of the system. 1.1 Class selection function. After entering the classroom management system page, we can see a similar page to the original education system. Then a glance can see system have class selection interface. Each into a different class had belonged to their respective student personnel. Users only need to use at this time the class can enter the page of the specific class. See in the specific class page of the system, there is a small switch of an interface, which is set on the left side of the page. This small function is convenient for users to use different functions without dropping to additional page again. And it also makes the page have a certain viewing experience. Picture 5. Conclusions. Although this project is a small project, it is not a simple thing for a beginner. Platform and development involves the main contain HTML5, CSS, and JavaScript. Each language has its own characteristics. A lot of time and attempts to really master it. In the specific class page on system, there is a small switch of the interface, which is set on the left side of page. This small function is convenient for users to use different functions without jumping to additional pages again. And it also makes the page have a certain viewing experience. Class 4. Class attendance. Classroom report. Class report. This is interface switching options. In bigger font, there's a class report. Although this project is a small project, it is not a simple thing for a beginner as web front and development involves the main contain merely HTML5, CSS, and JavaScript. Each language has its own characteristics. It takes a lot of time and attempts to really master it.
Dear judges, I'm going to introduce this paper named Hardware Design and Develop of Intelligence Metadata Acquisition Model. based on Wi-Fi. The author of this paper is Tang Ming, University of Electronic Science and Technology of China, Zhongshan Institute. The paper present that can be summarized as the purpose of design is to make a Wi-Fi based intelligent metadata acquisition model. It's mainly composed of HT6015 chip Wi-Fi model. The voltage and current signal are first entered into the relevant resistive and capacitance filter processing signal, filter counter, and so on, and then transmission to the RN8027C metering chip to realize the conversion of electronic energy into pulse signal, then transmit to the HT6015 chip to complete the static of pulse signal, and then to complete the static of electric energy. Finally, the power information is transmitted by the Wi-Fi model. The electrical signal in this system are first passed through the capacitance resistance to divide the voltage to product equal proportion signal, and are easily adjusted to input range of sampling port of matching chip. The low-pass filter is used to filter out the interference signal containing the useful signal so as to obtain the real power consumption and other information more accurately. After this chip, the electrical signal to the pulse signal is transformed, and then the electrical information can be obtained by processing the statistical change of this chip, and the Wi-Fi model can be transmitted as a result. By processing the statistical change of chip and the Wi-Fi model, and the Wi-Fi model can be transmitted as a result. The electric signal is collected, processing and transmitted quickly, which is the design of intelligent metadata model based on Wi-Fi. The keyword and the main point of our word is that Wi-Fi, smart meters, smart grid, Internet of Things. The following is introduction on the basics of electronic wire matter, the design of electronic integrated circuit is more optimized, both in the performance and in operation of the first than the original electronic watt-hour method has a great advantage compared with the original electronic watt-hour method. It has the following advantages. The first advantage is power consumption. The power consumption of a signal matter is only about 0.6 or 0.7 because of design of electronic component used in smart matters. If you need less power, you can make a multi-family matter-hour matters so that average power to the home can be smaller. The second is accuracy, because the mechanical wear of mechanical water-hour matter, such an insumerable congregation defect, will lead to mechanical watt-hour water walking more and more slowly. The final reading of the matter will be more and more errors. Electronic intelligence water matter does not have such defects. Overload and power frequency range. The overload multiples of smart matters can generally reach 6 to 8 times. With a large range, the frequency at work is also relative, can reach 40 to 100, while the overload multiples of original of ordinary inductive matters are generally 4 times. Far similar than that of smart matters, and the working frequency is also relatively small, which is much smaller than that of smart matter, so the working environment is not as good as smart matters. The following is system design. Overall system schemes. This design is mainly aimed at matter system, or a total of 8 main models. How it works is that the mattering model transmits the metadata to the CPU through the communication model of serial spot, but different models are used by providing different levels by power model. LCD display model is used to display all kind of electricity information of user. This storage model is used to manage events, electricity, and other data. Wi-Fi model is used to realize the interaction between devices communication and user information. The next is selection of major devices. Selection of main chips. This chip is the main chip selected for the design. For the new generation of smart matter application, the kernel uses a Cortex-M0 process with flash, power supply, and resist management, clock management, temporary sensors, hardware, how to make temporary compensation, RTC, high frequency RC, low frequency RC, and LCD driver, another rich IP, and the system hardware design. For the hardware design curriculum part of equipment, look up the literature and read and date. Determine the overall idea, then by selection whether the relevant hardware can meet the requirements of the whole system design. See whether to achieve the overall goal, to sort out the conformation ideas. Then complete the circum-dialog design, devices purchase, welding, and other work. Since the actual requirement for using to provide basic electronic information, then the use of power signal, the design, put into main chip, after sampling circular the desired electricity information, such as circuit frequency, power factor, power consumption, voltage. And from Figure 4, current simply circuit is including 3 resistance and 1 ground to C0805. From Figure 4, we can see that the current in circuit is filtered out by the low-pass filter and the current transformer into the chip. The larger current signal is induced into small m voltage signal through the current transformer into the current sampling signal. The loading resistance is used to convert the larger current signal in the transformer into smaller voltage, and the smaller voltage sign is adjusted to input a range that analog to digital. Sampling part can withstand and so get small signal. The current sampling signal of the small can be input into the different signal pin. And the last is conclusion. A data acquisition model of intelligence matter based on Wi-Fi is designed in this paper. Through analyzing the detailed data of chip and ESP Wi-Fi model, the current dialog of this model is designed and the code of related hardware is written, and the design and development of intelligent metadata model based on Wi-Fi is realized. And from Figure 4, we can also see that a current in circuit is filtered out by the low-pass filter, and current transformer enter into chip. The larger current signal is induced into small voltage signal through current transformer into the current sampling signal. The load resistance is used to convert the larger current signal in the transformer into small voltage. And so can get small signal. The current sampling signal of small can be put into differential signal pin after processing by lower filter. And we also can see that the current in the picture, the larger current signal is induced into smaller, and the analog to digital sampling part can withstand and can get small signal. At last, a data model of intelligence matter based on Wi-Fi is designed in this paper to analyze the detailed data chip and model. The circuit scheme dialog of the model is designed and code of related hardware, and design develop of intelligent matter data acquisition model based on Wi-Fi is realized.
self-organizing map for blood vessel segmentation of fundus images. We will introduce our paper with 4 parts, including introduction, our proposed unsupervised segmentation method, experimental results, and conclusions. Introduction. Automatic and accurate blood vessel segmentation method could provide several useful features for diagnosis of various retinal diseases and reduce the doctor's workload. Many methods have been proposed for fundus vessel segmentation, including rule-based method and machine learning methods. The rule-based methods include model-based methods, kernel-based methods, and adaptive thresholding methods. The machine learning method is divided into supervised and unsupervised method. The supervised methods train the classifier with prior knowledge, including support vector machine, base classifier, and k-nearest neighbor classifier. The unsupervised methods segment the blood vessels without any prior knowledge, including k-mean algorithm, fuzzy-mean method, and self-organizing map. Our paper presents an automatic unsupervised segmentation method to partition the fundus images into 2 types, vessel and non-vessel. Our proposed unsupervised segmentation method. The fundus images have low contrast and large variability is presented in the images acquisition process, which deteriorate automatic blood vessel segmentation results. Therefore, we expand each pixel of fundus image into a multi-dimensional feature vector, characterizing the image data beyond simple pixel intensities. Firstly, the green channel of the original RGB fundus image has better performance in the best vessel background contrast than the red and blue channels. Therefore, the green channel intensity is taken as the intensity feature of each pixel. Figure A is the original RGB fundus image from Drive database, and the green channel image is shown in Figure B. Fundus images often show poor contrast and noise. Wavelet theory provides a powerful framework to decompose images into different scales and orientations. We extract the wavelet feature from the high-frequency subbands of the before wavelet transform with scale 2, 3, and 4. Figure C is the high-frequency wavelet image with scale 2, 3, and 4 of Figure B. The shade correction method is used to remove the background lightning variations in this paper, but the contrast between the blood vessels and the background is generally poor in the fundus images after background homogenization. Therefore, vessel enhancement is utilized for estimating the complementary image of the homogenized image and subsequently applying the morphological top-height transform with a disk of 8 pixels in radius. Figure D is the vessel enhancement image. So, A multi-dimensional feature vector is constructed with the green canal intensity, the high-frequency features of the wavelet transform, and the vessel-enhanced intensity feature by the morphological operation. Method based on neural network is often used in Fundus image segmentation. As an unsupervised cluster method, Coin's self-organizing map is a 2-layer feed-forward competitive learning neural network that can discover the topological structure hidden in the data and display it in 1 or 2-dimensional space. In this paper, we use self-organizing map to clustering pixels in the founder image. Because vessels of the founder image belong to the detailed information, we set the size of output there with 4 multiply 4 to resolve the thin and small vessels in the segmentation results. After clustering with self-organizing map method, there are multiple neurons, including vessel neurons and non-vessel neurons, in the output layer. We use K-mean method to estimate the output neuron class, which labels the neuron class based on the neurons' inherent distance from each other. Figure A is the original RGB founder image, and Figure B is the manual segmentation results by the first specialist. Figure C is the segmentation result with our proposed method. Experimental results. In our experiments, the drive database is used and the segmentation of the first observer exploited as the ground truth. To classify the overlap between the segmentation results and the ground truth for vessel pixels and non-vessel pixels, accuracy is adopted in our experiments. We compare the segmentation results of different algorithms with our proposed method on drive database in terms of the average accuracy value. The result is shown in Table 1, which indicates our proposed method outperforms most of the other methods. Conclusions. Our study presents a blood vessel segmentation method based on neural network algorithm. Firstly, we construct the feature vector with the intensity of green canal, the wavelet transform, and the vessel-enhanced intensity feature to overcome the problem of low contrast and large variability in founder images. Then, we classify the pixels in founder images with self-organizing map method, and label the output neurons as vessel neuron or non-vessel neuron with K-mean method. Our proposed method is validated on the drive database. The experimental results are evident that our method is robust to the low contrast and large variability in the founder images. In addition, we compare our method with the state-of-art methods, and the experimental results indicate that our method outperforms most of the other methods. Thank you.
Hello everyone. Today my topic is the generation of virtual IHC staining images based on an improved Cycle-GAN. Colorectal cancer is the world's fourth deadliest disease. Pathological instrumentation has become an accurate and common method in the diagnosis of cancer, and the gold standard for pathological diagnosis. Pathological slices has significant application value in clinical and scientific research. The HE is a common pathological examination and is widely used in clinic. It has the advantages of high efficiency and low cost. The cells and tissue components can be clearly identified by the pathologist, and the cancer can be initial diagnosis and graduate. However, there still need enough contrast to differentiate some low-grade cancer areas, which can be diagnosed with IHC. The IHC is a molecular level staining. Meanwhile, the Ki67 protein is a cellular marker and can be used in IHC. It also used for qualitative and quantitative studies for cancer based on its staining results. However, Ki67 IHC examination takes a long time and has a high cost. Hence, the generation of virtual Ki67 staining sections from the HE staining sections by computer-assisted technology will be a good correction solution. The generation of virtual Ki67 staining images is similar to some natural images-related tasks, like state transfer, image super resolution. For this task, GAN gained more and more attention from the researcher. The GAN contains two sub-networks. One is a generator, and the other is discriminator. The generator is employed to generate fake similar data, which then is used to form the discriminator. The discriminator is trained by both real data and the fake similar data, which is employed to differentiate the fake similar data from the real data. The generator and the discriminator compete against each other. Once the discriminator cannot distinguish the authenticity of the images, it means that the generator has learned to model the distribution of the input data. At present, the common GANs include C-GAN, pixel-to-pixel, and Cycle-GAN. C-GAN is based on the GAN network and adds condition construction to the generator and discriminators. The condition can be labels or other model informations. The pixel-to-pixel network can be used to translate pixel-leveled paired images. The Cycle-GAN can be used to do state transfer between unpaired images, such as apple to oranges. Based on the Cycle-GAN basis concept, our framework, as shown in this PPT, translate the HE staining domain to the Ki67 staining domain without the need of paired image from both domains. It consists of two generator and discriminator pairs. The first pair is the generator HE to Ki67 and the discriminator of Ki67. The second pair is the generator Ki67 to HE and the discriminator HE. The generator HE to Ki67 try to map the images from domain HE to domain Ki67, while the generator Ki67 to HE try to map images from domain Ki67 to domain HE. The discriminator Ki67 try to verify if the image comes from the real domain Ki67 or the fake generated one. Similarly, the discriminator HE try to verify if images comes from the real domain HE or the fake generated ones. The loss function has three paths: adversarial loss, cycle consistor loss, thrush cycle consistor loss. The first is adversarial loss. It is important to match the distribution of the generated images to that of the target domain, and match the distribution of the generated target domain back to the source domain. The cycle consistor loss is to alleviate the lack of ground truth images for the fake images generated in a particular domain. The images is mapped back to its source's domain using the reverse mapping function. This loss ensures that the reconstructed images preserve similar structure as in the source domain. In addition, this loss goes in both directions, forward and backward cycles, to ensure stability. We introduced the structural cycle consistor loss to our model to regulate the structural changes between the input and output images. This loss is concluded based on the SSM, which has been used for assessing the image quality in many related studies. Our experiments dataset contains of 118 pairs of HE and Ki67 staining images with the size of 6,000.6,000, which are basically similar in tissue structure but not pixel level matched. We divided the total of the 118 pairs images into training and testing sets with 115 pairs and 13 pairs respectively. For the testing size, we use register technology to those images. Then dynamically wrap the Ki67 to the respective HE staining images. Due to the memory limitation, all the high-resolution training images were split into 288.288 tiles with 144 overlap. After tiling, our training datasets contain about 16,000 HE 288.288 RGB tiles and the same number Ki-7 tails. This picture shows the origin imaging, reconstruction imaging, and raster map between the reconstruction and origin images. It shows the improve of details impression. There is used four methods. The first is Cycle-GAN, the second is Cycle-GAN and skip connection, and the third is Cycle-GAN and SSM loss, and the fourth is our method. We evaluate and compare our method to several baseline methods by matching for evolution. For example, SSM, MSSSM, PSNR, and MAE between the reconstructed HE staining image and the source HE staining images. Compared with the other three Cycle-GAN baseline method, our purpose method shows a significant improvement. Meanwhile, the variant Cycle-GAN with skip conception and the variant Cycle-GAN with the SSM loss has also achieved relatively equal improvement, which means that both the skip connection and the SSM loss can improve the quality of generated image on detail impression. This picture shows the visual comparison of generated visual Ki-7 staining image. The A is original HE image, and D is reference Ki-7 image. B is generated Ki-7 image by Cycle-GAN. C is generated Ki-7 from Cycle-GAN and skip connection. E is generated Ki-7 from Cycle-GAN and SSM loss. And 4 is generated Ki-7 from our method. The qualification evolution results is presented in this table. Since our original data is not pixel level paired, so the pixel level evolution strategies are not suitable for this task. We mainly collect the feature from the second layer of ResNet 18. Then the average value of each channel feature is calculated. So then the generated staining image can be expressed by a channel level vector. Then the hash algorithm is employed to conclude the correction between the generated staining image and the reference staining image. Our purpose method achieves the state of art with the p-hash performance of 0.7787. The image generated by our purpose method is about vastly superior to the other results. This is all the reference.
Thank you, Mr. Chair. Nice meeting you, everyone. My name is Kemal from Nanjing University of Aeronautics and Astronautics. Currently, our team is working on the wireless channel sounding, modeling, simulation, and emulation. Today, I'm honored to be here and share our recent research results with you. My topic is a lower long-stationary channel model for UAV to vehicle millimeter wave beam communications. My presentation includes 5 parts. Firstly, I will begin with the background of UAV millimeter wave channel models. In recent years, due to high mobility, low cost, and easy deployment, the UAV is considered as a promising mobile communication platform. Moreover, the millimeter wave communication technology can integrate a large number of antennas into a small size and provide multi-gigabit transmit ability. Thus, for the upcoming 5G, beyond 5G system, the UAV-assisted millimeter wave communication has been considered as an important application scenario. However, compared with traditional land mobile channels, the UAV millimeter wave channels have some dual features. For example, 3D scattering, 3D trajectory, 3D antenna error, and 3D narrowbeam. This would affect the channel characteristics significantly and makes the traditional channel models inapplicable. Therefore, it is vital to deeply understand the UAV millimeter wave beam channel for the system design, algorithm optimization, and performance evaluation. Several UAV channel models for sub-millimeter wave has been proposed by upgrading the traditional deterministic channel models or geometry-based stochastic models, but were not applicable for the millimeter wave band. So far, most of the existing millimeter wave channel models focused on the land mobile communication scenarios, and only a few involved the UAV millimeter wave scenarios. All in all, the channel model considering all the new features of UAV millimeter wave communication scenario, especially the characteristics of beamforming, can be rarely found. To fill these gaps, we proposed a novel UAV millimeter wave beam channel. Next, I will have a brief introduction of the proposed channel model and its key parameters. Figure 1 shows a typical UAV to vehicle communication scenario. The UAV and the vehicle are both moving with 3D arbitrary trajectories in the 3D space. The UAV adopts the 3D beamforming to compensate the high path loss, and there are two local coordinate systems with their origins at the central position of UAV and the vehicle respectively. For the U2V communication scenario, the long stationary U2V channel can be modeled as a combination of loss part and long loss part. The loss part contains one direct path, while the long loss part contains several long direct paths with different delays. For the long loss part, in order to achieve the trade-off of complexity and precision, we have performed a huge number of simulations by retracing methods on the millimeter wave U2V channels. The simulated results show that the loss path, ground specular path, and two strongest single bounce paths cover more than 99% of the total received powers. Based on these results, we only take the ground specular path and the two strongest single bounce paths into account in the long loss part to reduce the complexity. And the loss path can be seen as a special case of the long loss path. For the U2V communication scenario, the UAV and the vehicle travel with 3D arbitrary velocities, and this factor is considered in the model, where the alpha t and beta t denote the azimuth and elevation angle of velocity respectively. And moreover, during the movement of UAV and a vehicle, the location of each antenna may change, and a rotation matrix is introduced to take this factor into account. Thirdly, I will demonstrate the hybrid channel parameter computation method in this paper. First, the geometric parameters are the basis to calculate the channel parameters. Due to the movement of UAV, the locations and distances all change over time. Here, we give the equations of the location and the propagation distance of the north path and the long north paths. It should be mentioned that the schedules are assumed to be static in this paper, and the VANET ones covered by the beamwidth are time-variant. Thus, the initial distance between UAV or vehicle and jet schedule should be reset as well. Based on the geometric relationships, the azimuth angles and elevation angle can be calculated. For the north path, the angles can be calculated by the relative locations directly. Different with the north path, each non-north path contains several rays, and the geometric parameters can only get the mean angles, which cannot reflect the random properties of the ray angle offset. Therefore, we can calculate the mean angles by the relative locations, and in this paper, we model the azimuth angle offset and the elevation angle offset as Gaussian distribution and Laplacian distribution respectively, which is recommended in the 3GPP. Similarly, the delay of loss path can be calculated by the distance directly, and the delay of the long loss paths are also divided into mean delay and random delay offset. The mean delay of the long loss paths can also be calculated by the distance directly. And here, the random delay offset is modeled as Gaussian distribution. For the path powers, in this paper, the power of loss path is normalized to be 0 dB. And for the long loss path, we can calculate the power of each ray by the exponential distribution according to the ray delays. Since the power of the north path is normalized, the one of the long loss paths can be normalized as this equation. In above equations, R tau and sigma tau denote the delay scalar and delay spread respectively, and the Zm follows a Gaussian distribution. Next, I'll show you the simulation results and analysis. The simulation scenario is a typical open scenario, and the schedules are generated randomly according to the characteristics of open scenario. Some of the simulation parameters are listed in the table, such as the geometric parameters, the carrier frequency, and the key factor, etc. Moreover, the beamwidth of UAV antenna arrow is assumed as 30 degrees, while the one of vehicle antenna arrow is 180 degrees. For the U2V mm beam channel, the angle parameters are more complicated and related with both the scattering scenario and beam width. Figure 2 gives the time-variant power angle profiles (PAPs) of loss path and long loss paths. It can be seen that the AOA and EALD are limited within the beam width, and the beam points to different direction at different time instants, and the vehicle antenna is usually close to the ground, and thus the EAOA range from 0 to 90 degrees. The time-variant power delay profiles, PDPs, of proposed channel model are simulated and given in Figure 3. In the figure, the delay and power of the north path are both normalized, and we can see that the long-loss path delay is time-variant. As we can see that the power of each non-loss path and each intra-path race show a trend of linear attenuation. It should be noted that the exponential distribution can be rewritten to a linear expression with respect to the power in dB. To verify the correctness of proposed mmWave channel model, two typical second-order statistical properties ACF and dPSD are analyzed. For the ACF, considering the similar characteristic of each non-loss path, we only take the first one into account. The theoretical and simulated results of ACFs, including the loss path and the first non-loss path, are shown in Figure 4. It can be seen that the ACFs change over time due to the time-variant channel parameters. Then we can get the dPSDs by using the Fourier transform of ACFs, and the simulated results in Figure 5 show that the Doppler frequency changes in a complicated way under the U2V communication scenario. Moreover, to further verify the consistency of proposed channel model with real scenarios, the simulated ACFs are compared with the field-measured ones in the literature. To the best of our knowledge, there are very few literatures involving UAV mmWave channel measurement, and none of them so far analyzed the measured ACFs. Since the proposed model is compatible for the sub-mmWave channel by adjusting some channel parameters, we choose a sub-mmWave channel measurement results to compare. So the beam width is ignored and some simulation parameters are reconfigured. The comparison result is given in Figure 6, which shows a good agreement between the simulated result and the measured one. Finally, I will have a summary about my research. This paper has proposed a U2V mmWave channel model by considering the 3D trajectory of UAV and vehicle, 3D antenna error, and 3D directional beam. Based on the propagation theory and retracing simulation results, the proposed U2V mmWave channel is modeled as a north path, a ground specular path, and the two strongest single bounce paths to achieve the trade-off of complexity and precision. And the channel parameters can be divided into a deterministic part and stochastic part related to guarantee both the correctness and the efficiency. And the simulated results are consistent with the theoretical and measured ones. In the future, we will perform the channel measurements to further verify the results and apply the proposed model to the optimization of beamforming and tracking algorithms for UAV mmWave communications. That's all of my presentation. Thank you for your listening, and all questions are welcome.
Hello there, myself Naim Ahmed. I'm a student of Electrical and Information Engineering College from Nanjing University of Aeronautics and Astronautics. Welcome to my presentation. First of all, utmost thanks to the EAI community for accepting my paper and giving me the opportunity to present myself. The presentation topic of mine is about a V2V channel simulator for velocity variations in non-isotropic scattering scenarios. First, I would like to introduce about the presentation contents, which consists of abstract introduction, reference model, proposed simulator, and a parameter computation, stochastic properties for proposed methods, simulated and analyzed results, conclusion, references. In this slide, I'm going to give you a brief idea about this paper, where a V2V channel model is proposed based on the velocity variations of MT and MR, which stands for mobile transmitter and mobile receiver. The method is to simulate the non-stationary fading channels under non-isotropic scattering scenarios. This method can be used for real V2V channel model scenarios. The analytical mathematical properties like PDF, SEF, and DPSD are studied and executed under VM distribution in this paper. Simulation results show a well understanding between the analytical and emulated results, which ensures the efficiency of both the suggested method and derivations. Next slide is about introduction. V2V propagation channels have a great importance on the purpose and execution of novel communication protocols for vehicular ad hoc networks, with consideration of a general design for non-stationary V2V channels with moving scatterers and terminal velocity variations, like mobile-to-mobile non-stationary channel model introduced with dynamic velocities and trajectories. Under multiple conditions, the channel model plays an essential role in designing, validation, and optimization of communication system output. The geometry-based stochastic model, GBSM, is a mainstream kind of modeling V2V channel in recent years due to its moderate accuracy and complexity. The channel is always changing constantly in the real world due to the moving objects and multiple bounds scattering. The non-stationary V2V channels allowed different velocities for both stable and moving scatterers. For both the loss and unloss cases, moving scatterers have an important contribution in the wideband V2V channels. The V2V GBSM takes into account the variation in velocity of terminals along with moving scatterers, the measurement of real channel parameters and movements at different traffic conditions. Here, as we can see, I mentioned few references. The main idea of this paper is to introduce a V2V channel simulator for velocity variations in non-isotropic scattering scenarios, and also the complex channel coefficient, which is much more complicated, comes to in consideration in this paper. The corresponding statistical properties like PDF, SEF, and DPSD are also studied and executed under VM distribution scattering scenarios. Moving on to the next slide, which is reference model. As we can see, figure 1, which shows a communication scenario of V2V channel model with velocity variations, where the transmitter and the receiver are moving with different time instants, which can be denoted by Vt and Vr, where the velocities are at linear form, which is also varies with the angles and direction of movements. The standard V2V communication scenario, where the transmitter and the receiver are moving with time-varying velocities, there are several propagation paths in the V2V communication system, and each path includes several subpaths. The velocities of transmitter and receiver are in an initial distance, in which the angle between arrival signal with the direction of movements can be at the linear form of velocity variations. In the next slide, I included some equations to the reference model. The time-variant channel impulse response between the transmission and the receiver can be represented under non-scattering scenarios as like the first equation, where n is the number of propagation paths distinguished by path delay tau n, the power Pn, and channel coefficient Hn. The second equation is the channel coefficient equation for the number of subpaths n. Fn is the time variant Doppler frequency, and at the phase theta n is periodic over pi to minus pi, and can be represented as an independent, evenly distributed random variable over pi to minus pi. Next, the third equation is the complex channel coefficient, can be described as like the third equation, where Fn is the time variant Doppler frequency and the initial phase is theta n, which is periodical over pi to minus pi, and Fn is the discrete Doppler frequency and can be calculated like the fourth equation, where V denotes the amplitude of velocity, lambda is the wave number, and alpha n is the angle between arrival signal with the direction of movements. Moving on to the next slide, which is proposed simulator and parameter computation. Here are two subsections of this section. The first one is proposed simulation method. The first equation is the proposed method for this paper, where n is the number of seesaws, theta n is the initial phase of each path, and can be developed by distinct random variables distributed over minus pi to pi. Doppler frequencies will be time variant for the non-stationary situation due to change of angles or velocities over time, which can be modified like the second equation. The time variant Doppler frequencies for this proposed method can be generated like the third equation. By merging all the equations, we can get the channel coefficient equation like the fourth one. The next subsection is computation of time variant Doppler frequencies. The time variant Doppler frequencies only depend on the amplitude of velocity for a short time period. The speed can be approximated by a linear model like the velocity equations at the right side, where V0 and A0 are constant, describing the initial velocity and the rate of change of velocity. By describing of the velocities, we can get the channel coefficient equation like the second equation. The next slide is about stochastic properties for proposed methods. Here are also three subsections. The first subsection is time variant PDF. For deriving the PDF of the proposed method, it can be described as like the first equation here, where mu tz can entirely be described by the variables of n, sigma mu, and k, while the frequency variables have no impact. Thus, at every time period, sigma mu and kt are stable. The second subsection is time variant SEF. The SEF for non-isotropic scattering scenarios is a time variant and corresponds both function of time lag tau and time t. The time variant SF could be specified like the first equation of SEF, RHH equals to RMM plus R mu mu, where RMM and R mu mu denotes the path components. The SEF changes over time delay as we can see by those equations. The time variant SAF with the VM distribution scenario can be described as like the R mu equation. By accumulating the RMM equation and the R mu equation, we can get the final SAF. The third subsection is time variant TPSD, which could be represented as like the first equation here. By the help of Wigner-Weil distribution method, we can describe the TPSD as like the second equation, and the second equation could be withdrawn by building over the faces, and the TPSD can be look like the third one. Here's now the simulated and analyzed results. As we can see in figure 2 and figure 3 describes the PDF and SAF for different time instants like 0, 1 and 2 seconds, which are compared with the interrelated theoretical results. The simulation values generated by the improved method proposed in this paper are consistent with the analytical values of the reference model, and as the simulation time increases, both the PDFs and SAFs of the channel changes from Rayleigh distribution when t equals to 0 to Rice distribution when t equals to 1 and 2 seconds. The larger the number of time the simulation, the closer the value of the simulation will be to the analytical value, and the higher the accuracy of the simulation will be. Next, I'm going to talk about the two different scenarios of TPSD. As we can see in figure 5, here are scenario 1 and scenario 2, which shows the time divergence of the loss components along with the time path by the effect of velocity variations under different scenarios. Scatterers' movements are considered to be evenly distributed across terminals. The transmitter and the receiver are shifting in two different scenarios along with the different velocity patterns. The Doppler frequencies are computed and differentiated in figure 5, as we can see. For two different scenarios, the maximum Doppler shift in scenario 1 and scenario 2 are slightly changed from each other, which also specifies the movements of scatterer. Those figures clearly show that the emulated Doppler frequencies of the designed method matched well with the analytical result. As for the Doppler frequencies shifting over time, which can clearly be observed, means that the velocity parameters Vt and Vr and also the acceleration parameters At and Ar are affecting the Doppler shift along with time, which proves the perfect understanding between the analytical and emulated results. Figure 5 shows that the DPSD of analytical and emulated results for the scenario 1 and scenario 2 of velocity variations with moving scatterers, which is the result of the non-isotropic scattering scenarios. Now the conclusion of this paper. As I mentioned before, a V2V channel simulation method is proposed for non-isotropic scattering scenarios, including velocity variations. Both the mobile transmitter and the mobile receiver allows velocity variations in this simulation method. By adjusting the time variant channel parameters for the velocity variation, this method shows a well understanding between the channel characteristics. In this simulation, the analytical results for the PDF, SAF and DPSD under VM distribution scattering scenarios are derived. Simulated results shows that the proposed simulation method provides very close approximations to the desired theoretical characteristics. And now the references of this paper. Here I mentioned all the references of this paper, and that's all of my presentation. Thank you.
Hello everyone, this is Tong Zhang from School of Electronics and Information Engineering, Harbin Institute of Technology. It's an honor to be here to give this presentation and share our research results. Now I'm going to talk about energy efficient communication of field-powered UAV relay, design of positions, and power allocation. My presentation consists of 6 parts. First, I will introduce some background information about this topic. Then I will describe the system model. Next, I will talk about the way to solve the non-convex energy efficient problem. Then the algorithms are summarized in Section 4. In Section 5, the numerical results are given to discuss the influence of the power supply and the UAV's positions. At last, I will give a brief summary. There are several types of UAVs according to the energy support. Electric UAVs, fuel cell UAVs, and fuel-powered UAVs are the commonly used types. Electric UAVs are powered by electric batteries. They are affordable, easy to control, but have shorter flight time because batteries have low energy density. Fuel cell UAVs are equipped with fuel cells, which transfer the chemical energy to the fuel, the chemical energy of the fuel to electricity. However, they are quite expensive, require long start-up time and a suitable environment to work. Fuel-powered UAVs are driven by internal combustion engines. Fuel-powered UAVs have long endurance of flight and is adaptable to different environments. They have drawbacks such as noise and pollution, but are irreplaceable when high load, long endurance, and low budget are required. Different from electric UAVs, of which the energy efficient operation is quite important because the communication part and the operation are powered jointly by electricity, and the operation consumes much more energy than the communication part. As the fuel-powered UAVs has different power supplies for the mechanical operation and communication. Because the UAV's operation is powered by fuel and the communication is powered by batteries separately, so considering the energy-efficient communication is important. In our research, we focus on its energy-efficient communication process, and we want to see how the battery power may influence the communication process and how we should decide the UAV's positions to achieve higher energy efficiency. We consider 2 situations: the UAV working as a one-way relay and working as a two-way relay. The air-to-ground channel model is line-of-sight channel. The data rates are given by 1 and 2. We denote the UAV as A. There are 2 ground nodes numbered as K. the channel gain HAK and HKA are calculated according to free space path loss. Here we notice that the distance between A and the ground nodes and the communication power PA and PK all influence the data rates. Also, the energy efficient functions are complicated because it is non-convex about the coordinates of the UAV XA, YA, and the communication power PAK. The two constraints are information causality constraint and the power limitations. Two-way relay has similar forms, but the information causality constraint is different. The sum of R up is the sum of the data transmitted from the ground nodes to the UAV, and the sum of R down means the sum of data transmitted from the UAV to all ground nodes. Here we leave out the length of time for brevity. To solve the non-convex problems, we add a slack of variables and use the SCA method, which is the abbreviation of Successive Convex Approximation method. We introduce a slack of variables @check for the energy efficiency. @check is updated after each iteration of the SCA method, and we transfer 10 to an equivalent function 12 by using its logarithm and first-order Taylor expansion. Then we introduce a lower bound of R, which are 13 and 14. The lower bound of RAK is RCheck AK, and the lower bound of RKA is RCheck KA. The lower bounds should be smaller than RAK and RKA, so we add the convex constraints 15, 16, and 17. As for the upper bounds, by introducing the slack of variables phi AK, we have the upper bounds of data rates RAK. Similarly, the upper bound R hat AK should be larger than RAK. We need to add it as a constraint, which is transferred to convex constraint as written in 19. Here, beta k is also a slack variable. Now, according to SCA method, we need to update the following variables after each iteration. Based on the former process, we can transfer the non-convex problem to a convex problem. And here, at each iteration, we solve the convex problem P1 for the increments and update the variables. Similarly, the energy-efficient problem of two-way relay is also transferred to a convex problem. The procedure is summarized in algorithm 2. Next, some simulation results are provided to verify the performance analysis of the proposed algorithms. In this section, we show the numerical results of the proposed algorithms. The ground nodes are fixed. The distance between the two ground nodes is 2,000 meters. The height of the UAV is said to be 100 meters. The communication system's bandwidth is 20 million Hz and work at 5 gigahertz. So the parameters of line of sight path loss at a reference distance is minus 46 dB. The path loss exponent is said to be 2. The noise spectrum density is minus 169 dBm per Hz. The circuit power is said to be 0.02 watt. Figure 1 shows the convergence of the proposed algorithms. The line with triangles shows the convergence of the results for one-way relay. The algorithm converges after 13 iterations. The line with squares shows the convergence of the energy efficiency of the two-way relay. The algorithm converges after 8 iterations. From Figure 2 and Figure 3, we can see that the upper bounds and lower bounds converges to the same value, which proves the validity of the proposed upper bounds and lower bounds. This implies that the constraints we have derived using select variables and increments of the SCA method will be satisfied with equality after enough iterations. So the transformed convex problems P1 and P2 are equivalent to the original problems. In addition, we need to mention that since we only focus on the energy efficiency of the UAV, the power from the ground nodes are not specially considered. If the ground nodes have abundant power supply, the results of our check Ka may be higher than what is needed. This is because we did not focus on the energy efficiency of the user's part. So as long as it does not violate the information causality constraints, our check Ka is not especially minimized. Next, as can be seen from Figure 3, with more communication power, the system energy efficiency increases. But as for the two-way relay, the value increases and then goes stable quickly. This is because the UAV does not change its position, and once the optimal power allocation is achieved, the results do not change anymore. As for the one-way relay, with higher power available, which are constraints for both the ground nodes and the UAV can move nearer to the destination node for better channel condition without violating the information causality constraints. Then the energy efficiency can be further increased. Corresponding to Figure 3, we can see from Figure 4 that with more power available, the UAV as a one-way relay moves near to node the receiver, while the two-way relay, the UAV stays in the center between the two ground nodes. This is because for the one-way relay, with more power available, node 1, the transmitter can transmit with higher power to the UAV. To maintain the information causality, the UAV can move nearer to the destination node for better channel conditions, so as to save its communication power. This increases the energy efficiency of the UAV, but as for the two-way relay, the UAV needs to communicate with both of the two ground nodes. So neither moving to node 1 nor moving to node 2 helps to save energy. Also, as can be seen from Figure 5, the UAV as a one-way relay decreases its power when more power is available, because it moves to the receiver, and the two-way relay increases its power, then keeps it stable. we did not set priority levels of the ground nodes. So the UAV can communicate with node 1 and node 2 with equal power because the channel conditions are the same. Finally, as a summary, we studied the energy efficiency problem of a UAV relaying system. We proposed the upper bounds and the lower bounds of the data rates to transmit the non-convex problem to convex, and we solved the problem using SCA method. Our numerical results show that the one-way relay moves nearer to the destination node when more power is available, but the two-way relay has to transfer information to both of the two ground users, so staying at the center is the best solution. Thank you for your attention. If there are any questions, please contact me by email.
Hello everyone, my name is Wei Hu. It's my pleasure to report my research. Today, I'd like to say something about a lower energy optimization approach, which topic is energy optimization with adaptive transmit power control for UAV-assisted data transmission in VANETs. Here, I will introduce my presentation from these aspects. Part 1, Background and Related Work. Part 2, Problem and Challenge. Part 3, System Model. Part 4, Solutions, Results. Part 5, Simulation. And Part 6, Conclusion. And 7, Part References. Firstly, please allow me to introduce the current research background. As we can see from the first two pictures, the rapid development of society has gradually increased the number of vehicles on the road. But many remote suburbs and some urban roads have low deployed ISU, and road information cannot be exchanged in real time, which will cause communication delay. In picture 3, we can see is a UAV. The UAV can act as a relay to provide temporary data transmission, and the UAV deployment is cheap and flexible. However, due to the energy of UAV is limited, so the time for unmanned aerial vehicle assist to promote the efficient data transmission is limited. To this end, improving the endurance of UAV has become a crucial issue. Here are some few important examples of related work, mostly showing the research progress of energy optimization and adaptive. We can see in 1946, H.T. Ferris proves the relationship between transmit power and received power in one clear line of sight paths. And in 2019, Yang Zeng, Xu Jiexu, and Rui Zhang represent a duration of population power consumption model of the UAV. However, optimization of the energy of UAV faces many problems and challenges. It is worth noting that many existing research methods had not considered the relationship between the dynamic loads of the UAV and the vehicle on energy consumption. The existing methods may only optimize the flying energy of the UAV, Besides, a lot of researchers echo the communication energy of UAV. We also know high-speed topological relationships also make energy optimization more difficult, and the communication delay will increase when communication link is broken between vehicles. Close to home, here we'll introduce the system model as shown in this picture. In the front end of and rear ends of the road deployed and roadside unit that collects information on road traffic conditions. A section of ISU that is load covered is divided into a series of sub-segments, and each road section is provided with a UAV to provide network services. There are three main communication methods among the UAV. We can see is the real-time information about traffic condition is shared among the vehicle via V2V communications, and ISU share information to UAV via ISU communication, and the UAV transmit occurred information to the vehicle via U2V communications. Many studies shows energy consumed by the UAV to maintain flight at altitude population, we call the flying energy. And on the other hand, communication energy which used to communicate with sensor nodes on the ground, such as vehicle, base station, and so on. So we can get the general formula of the energy, E equal E fly plus ecom, such as these pictures. In the actual situations, your UAV's trajectory may change dynamically, but due to its high altitude and high acceleration, and we not consider the acceleration and deceleration because the vehicle drives straight on the road, and UAV provide information transmission from ground to vehicle, so we can get the flight energy of UAV. Here, where V represents the speed of UAV, and V0 represents the speed of a target vehicle. Similarly, the communication energy of UAV is also equal to the energy consumed by UAV for acceleration and deceleration. When we can see in these pictures, when the vehicle enters the coverage areas of the UAV, it starts to communicate. The relative distance between the vehicle and the UAV is relative to the distance projected on the ground. We can see where X represents the relative distance between UAV and vehicles. X changes from R to 0, and then from 0 to R. Equation 3 is the UAV transmit power formulas, and equation 4 represents the communication energy of the UAV. Based the above analysis, we combine the limit of the energy and the range of the speed. Now is equivalent to finding the optimal speed of this combination formula. We consider the relative distance between the UAV and the vehicle and the adaptive power. So how to solve the problems? Here, for easy of presentation, we use P and V to represent the following values. So the model can be simplified as this following. Here, note that the constraint 1 is a non-convex constraint. Therefore, the problem is hard to solve, but the images of the objective function readable as a checkmark function. Notice the first so we can use the serial 1 by proving the monotonicity of the objective function and confirm and there is a unique solution. And since the images of the objective function looks like a checkmark function, so serial 2 can be obtained by using the principle of equality. Here is the use of equality method to find the optimal value. If V greater than V0, the optimal solutions to allergy optimization problems can be expressed as such as. Here is a proof of serial 1 when V greater than V0, the problem is differentiable on the interval. There is one stable point, and we can use Rawls theorem to prove that. And here is the proof of serial 2 using equivalent subsummation. You can see the characteristic of the functions more clearly. It can be found if we set a k equal v minus v0 to change the element. In the next, we can get the equations. Now it's our simulation results. In this picture, we found the energy consumption on the optimized algorithm is more energy efficient than the optimized algorithm. In this picture, the optimized algorithm improves the endurance of the UAV when the distance between the UAV and the vehicle is increased, and the threshold values of receive power set by the vehicle is not changed. The energy consumption is also increased as the altitude is increased. We further found that this effect is great with increasing height. In this picture, we plot the change in the energy of the two algorithms with the UAV's coverage radius. It can be seen that as the radius r increases, the energy consumption of the UAV also increases accordingly. Because of the large range of implementation, the coverage of the UAV needs a lot of power, which will consume a lot of communication energy. Because this paper uses adaptive transmit power, as long as it grants a certain communication time, it is considered that the energy under the optimization algorithm is completed and the performance is improved compared with algorithm without optimization. It can be from In this picture, it can be found that when the speed of the UAV communicates with the vehicle, the closer it is to the speed of the vehicle, the longer it takes to service the vehicle, and the more energy consumption during data transmission. And in order to verify the advantage of our algorithm in energy optimization, we compare it with algorithm has not been optimized in communication energy. We observed that the greater the UAV speed, the shorter the data transmission time, and the closer the optimization algorithm is to the energy without the optimization algorithm in energy consumption. Overall, the optimized algorithm will save a certain amount of energy. All in all, now, we focus on contributions in our presentation. First of all, we promote the energy optimization model to improve the endurance of UAV. And by considering the relative position between UAV and the vehicle, adaptive transmission power is applied to communication energy consumption. Second, we order to verify the extent of the solutions. We use real serial and use the principle of inequality to get the solutions. And lastly, compare with optimized algorithm and algorithm without optimize the communication energy, and our proposed algorithm, which performance is better than the existing energy optimization algorithm. Here are some references in this presentation. That's all. Thank you for listening.
Thank you, Ms. Chair. Nice meeting you, everyone. My name is Zhang Dongyang. I come from Nanjing University of Aeronautics and Astronautics, and currently doing some research about channel emulator. I'm honored to be here and share our research results with you. Today, my topic is implementation of non-stationary channel emulator based on USRP. My presentation includes 5 parts. Firstly, I will begin with the background of channel emulator. Wireless communication systems have played an important role in many important fields, such as satellite communication, telemedicine, and mobile communication. In order to ensure the security and reliability of wireless communication systems, measurement campaigns should be taken into account under realistic conditions. However, field tests are expensive and unrepeatable, which means large-scale test scenarios are limited. Alternately, the channel emulator can reproduce the real channel in the laboratory for fast prototyping and performance evaluation of wireless communication systems under different conditions, which greatly reduce the research and development costs and the production cycles. There are several commercial channel emulators available, such as EB ProfSim C8 and the Sparent SR5500, which are extremely bulky and expensive. Moreover, they are mainly designed for standard channel models and inflexible to customize different functionality. The hardware architecture of some researches mainly focus on the specific algorithm verification, which is not suitable for channel emulation of all kinds of feedings. To the best of our knowledge, traditional emulators are designed for one-sense stationary. However, a large number of research prove that the real channel have non-stationary characteristics. This paper aims to overcome the problem. The major contributions and novelties of this paper are summarized as follows. Considering the abrupt phase change characteristic between adjacent channel states, a sum of linear frequency modulation (SOLFM) method is proposed to generate non-stationary channel fading with continuous phase. Based on the modular design of virtual instruments, we can focus on the architectural and algorithmic issues which are of great significance for design. A low complexity universal hardware architecture is proposed and validated with the idea of SDR. A channel emulator is designed and implemented to efficiently reproduce multipath fading, such as Rayleigh fading, Rice fading, and log normal fading, and reproduce the characteristics of the propagation in the laboratory. Secondly, I will have a brief introduction of the proposed channel emulator. Affected by the reflection and the scattering of obstacles in the complex wireless communication environment, the signal reaching the receiver are made up of multiple paths with different power and delay. In the condition of no obstacles between the transceivers, the signal travels in a straight line, which is called line of sight loss path. Otherwise, it's a non-line of sight non-loss path. Considering that FPGA has the characteristics of discretization and fixed point operation, we propose a model which a discrete channel impulse response (CIR) can be expressed as follows, where L is the level of discrete sequence obtained by sampling the time domain signal. Zeta denotes the level of discrete sequence obtained by sampling the delay domain signal. Ts represents the sampling period. Tau loss and tau non-loss denote the rounding delay result of the loss and non-loss paths, respectively. In order to accurately reproduce a wireless channel in a physical environment, we design a flexible and reconfigurable channel emulator on the basics of formula above. The emulator is designed by LaVille FPGA model under National Instrument USRP Rule 2943R software-defined video platform, which is equipped with a Xilinx Kintex 7 FPGA. As shown in Figure 1, the channel emulator is made up of 3 units: User Interaction Unit, Signal Conversion Unit, and the Channel Simulation Unit. The User Interaction Unit provides a vision operation interface for users to configure associated parameters such as path delay, fading type, and spectrum shape. In the meanwhile, the RF input signals are down-converted and sampled to digital complex baseband signals by the Signal Conversion Unit as a core part of the simulator. The Channel Simulation Unit generates a non-stationary channel fading by sum of linear frequency modulation (SOLFM) using the parameters above and combined with the digital signals to produce a wireless environment. Thirdly, I will demonstrate the non-stationary channel fading emulation. Transition channel emulator often use sum-of-suicide method to generate channel fading coefficient. The essence of the method is the sum of harmonics with different delays and power, taking the place of the effects of direct radiation, scattering, reflection, and refraction during the wireless propagation. However, this method doesn't take into account the real-time changes of the channel parameters caused by the movement of the transceivers or scatter. In other words, the channel doesn't meet the condition of white-sense stationary. In order to solve the problem and reduce the complexity of hardware emplacement, this article adopts the SOLFM method to generate non-stationary stochastic fading. Meanwhile, due to the time-discrete characteristics of the hardware implementation, the model is further discretized as follows. The embedded Kintex 7 FPGA on the USRP software-defined radio platform allows for the fast hardware implementation of the algorithm above. The hardware implementation with virtual operations by level FPGA model include two key components. An embedded block RAM and ROM generate frequency control word and initial phase. Meanwhile, the lookup table combines the signal above to generate a time-varying fading with continuous phase based on the concept of DDS. As for implementation of the real-time delays in the tap delay line TDL architecture, which is capable of performing the real-time convolution calculation by sampling complex multiplication and addition. Embedded dual-port block RAMs is adopted for parallel processing and real-time performance in Fig 2. Limited to the sample rate of 100 MHz, the resolution of the delays is 10 nanoseconds, which satisfies the requirement of actuals for most radio devices. Meanwhile, the maximum delay is decided by the depth of embedded block RAM available per pass. Configuring the depth of 10,000 can reach up to delay of 100 microseconds, which is large enough for outdoor environment. Following the above prototype design with the help of level FPGA model, the whole channel emulator has been successfully implemented on the USRP SDR platform. It hosts an embedded Kintex 7 chip, which consists of about 500,000 slice registers, 250,000 slice LUT, 800 block RAMs, and 1,500 DSP-48. Taking one path for example, Table 1 summarizes the resource consumption after synthesis and implementation at 100 MHz using level built-in local compiler. It can be seen from the table that DSP-48 and block RAMs consume large amounts of resources, which occupy 90.6% and 16.7% respectively. It mainly derived from the TDL. for multiplication and addition operation, and the channel delay for embedded block RAM, considering the intrinsic consumption of the module. The embedded source is enough for 4 paths. Next, I will show you the measurements and validation. As shown in Figure 3, the waveforms are obtained by an oscilloscope Agilent N9340B. Moreover, a large number of measured waveform data are taken for statistical analysis or PDF by MATLAB. It can be seen that the maximum iteration of the rise distribution is 1.48%, and the statistic Bayesian k-factor, k equals 1.02, is constant with the input one, k equals 1. The released PDF deviation is 0.14 dB, and the maximum iteration of the normal distribution is 3.89%. In the meanwhile, the output of DPSD is shown in Figure 4. The results show that the measured value is in good coincidence with the theoretical one, and the emulator produced a physical channel which is similar to the natural one. Finally, I will have a summary about my research. In this work, the design allows to generate time-varying channel fading with continuous phase, such as relief fading, rise fading, and normal fading in the library. It solved the problem that the wireless communication system cannot be quick tested and gradually reduce the research and development cost. Furthermore, hardware measurement results have demonstrated that the measured PDF agree well with the theoretical one. In the future, we will improve the delay accuracy of the channel emulator and apply the channel emulator to evaluate it and optimize the performance of wireless communication system. That's all. Thank you. All questions are welcome.
Hello everyone, my name is Yue. It's my pleasure to give a presentation here. As a student whose research direction is unmanned aerial vehicle, referred to as UAV, Advanced Vehicular Network, I would like to introduce my main research content to you. The title of my paper is Throughput Mechanization for the System of UAV as Mobile Relay Between Moving Vehicles. As you can see on the slide, my presentation mainly consists of the following parts: the research background, existing problems and challenges, my contributions, system model, solution method, simulation, and conclusion. Well, let's move on the first part of this presentation. Every one of us can actually feel it that the popularization of vehicles has made the road situation more complicated and the road congestion more serious. and the communication between road vehicle units, referred to as ISU, and the vehicles can obtain vehicle journey information, but their communication ranges are limited. And it was found that the UAV is widely used because of their flexibility and low cost. Many scholars have studied the UAV as mobile relays. However, in the existing research, the source and destination nodes of UAVs as mobile relay systems are mostly fixed. And the amount of data that needs to be successfully transmitted as the UAV, the flight energy limit of the UAV, and the communication range limit of the source node are not taken into account. Based on the above discussion, our main contributions in this paper are as follows. Firstly, we propose a throughput optimization model of UAV as a mobile relay between more vehicles. Secondly, consider the constraints of UAV population energy, the limits of vehicles' communication range, and the amount of data needs to successfully transmit in the purpose of UAV as a relay. Now, I'm going to focus on the system model, as shown in the picture. Vehicles on the road need to forward the information to the ISU at one of the roads. And the vehicles form a single cluster due to the limitation of their communication range. Vehicles in the cluster can communicate by means of single hop or multiple hop, but the communication between the clusters cannot be carried out. Therefore, we can introduce the UAV as a mobile relay between two clusters and communicates with the cluster head vehicles of the two clusters, thus establishing the communication between the two clusters. As a mobile relay between more vehicles, UAV may have two working modes. One is to have relatively with vehicle A, that is, the vehicle is at the same speed as the vehicle A. And the other is to exceed the speed of vehicle A and fly forward. As the UAV continues to fly forward while serving as a mobile relay. For upward communication, according to the channel transmission rate formula, we can get that the transmission rate between the vehicle A and the UAV can be expressed as like this. And this represents the communication distance between the vehicle A and the UAV over time. And the total amount of data uploaded by vehicle A over a period of time is the integral of its transmission rate over a period of time. For the downward communication, in the same way, we can get the transmission rate between the UAV and the vehicle B like this. and this represents the communication distance between the vehicular V and the UAV over time. And the total amount of data downward by UAV can be expressed like this. Only within the communication range of vehicle can it forward data to the UAV. So the transmission time is the communication range of vehicle A divided by the relative speed of the UAV and the vehicle A. And according to the reference, the flight energy consideration in the process of UAV as mobile relay can be expressed like this. Then, when the UAV is hovering relative to vehicle A as a mobile relay, that's to say the speed of UAV is the same as vehicle A. For the total number of information bits transmitted by uplink and downlink communication, as shown below. The total amount of data uploaded by vehicle A is QAH, and the total amount of data downloaded by UAV is QUH, and the flight energy concentration in the progress of UAV as a mobile relay is EFH. According to the above discussion, our objective function to maximize the throughput of UAV as mobile relay system can be expressed as the total amount of data transmitted during UAV as mobile as relay divided the total transmission time. Subject to UAV flight energy. The flight energy limited of the UAV in the relay process is less than a certain surge max. Subject to the amount of data required to be transmitted during the relay progress can be expressed as like this. That means the total amount of data transmitted by UAV is greater than the required Q, but it is impossible to transmit more than the amount of data transmitted by vehicle A to UAV. For the different relay models of UAV, we introduced an indicator function here, which can make the objective function get the unified expression. We also solved the objective function separately. When UAV maintains relative current, that's to say the speed of UAV equals to the speed of vehicle A. We prove that the objective function is mathematically decreasing. According to monotonicity, when satisfied with QUH equals to Q, and TH is satisfied with, the maximum throughput can be obtained. When UAV fly forward, we prove the objective function is convex and satisfy the TTT condition. We construct Lagrange functions like this, and according to TTT conditions, we can get the solution. Next, we carried out a simulation to verify the co-coordinates and the effectiveness of our model. These are some simulations set up in the simulation. We set off different vehicular speeds respectively for comparison, and then it can be found that as the amount of uploaded data increases, the smaller the speed difference between vehicle B and vehicle N, the greater the throughput of the system. And then we compared the throughput changes of UAV as a mobile relay in relative higher model, Lattice-Free model, and our purpose optimization method, with the speed of vehicle A is 10 and the speed of vehicle B is 15. And we can see in this picture, we can verify that our method is superior to our method. Also, we compared the throughput changes of UAV as a mobile relay in relative higher model, Lattice-Free model, power optimization method, and our purposed optimization method, with the vehicle A and vehicle B are equals to 10. As shown in the picture. We can also see that our method is superior to other methods when the vehicle A and vehicle B in the same state. To sum up my presentation above, in this table, we propose a throughput model of UAV acting as mobile relay between vehicles, which is proposed based on the actual vehicle networking scenario. Secondly, we consider the limitations of vehicular communication range, the limitations of UAV flight energy, and the requirements of data transmission during relay are considered. Thirdly, we use Lagrange multiple method to solve the problem. Above is my speech of this time. Thanks for your listening.